Sound check.
Holy cow. It always comes through loud and clear there, John. Thank you. All right. Welcome, everyone, to the Keshe Plasma Reactor group for Tuesday, December 29th, 2015. This will be the last show of 2015, and it's been a very interesting year. And I've got a picture up there now of let's get my sound connect there. This is a little crystal, kind of a crystal garden that I put together. It's just sodium tetraborate crystals, which is borax essentially. And there's a quartz crystal in the middle, but that's not growing. The rest of it is, it grows every day. It's quite amazing how much it does grow. It started out as about a 1/4 inch of clear liquid in the bottom of this container, and it just grew and formed these layers and decided to sort of reach for the sky. I think it's quite interesting the way crystals tend to want to, in effect, levitate. Salma, your microphone was open. That's a bit of interference there. Okay, so let's get going here and see what people want to talk about, what we have to show and tell and whatnot. Any comments or ideas off the bat here? Yes, hi. Is that Annabelle? That's commonly known as borax. You know what? You've heard of borax that's used in soap and so on for cleaning. Just a sec. I'll get the box. I'll show you. So let me just see if I can. I see. There we go. Let me just, I need to put this on the other window. Just a second here. Get this set up. Pin that on the second screen. And open that up. And then I've got to, there we go. Well, that's right. They haven't changed this since about the 1920s or something like that. But this is actually very, very interesting substance. This used to be sold by Ronald Reagan. He would show it up, and blah, 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 and, buy borax in the early days. And there's a site, actually, maybe I can bring it up here, that's very, very interesting related to this. Just a second here. Wasn't quite prepared. Oh, there it is. And well, that's true, and you have to be careful about drinking too much of it. But yeah, it's actually a very important element, and it's some parts of borax are interesting from a nuclear point of view. You can see the window I have up there. This is the Polywell nuclear reactor, which you can see up in the upper left-hand corner, which is very interesting. You see all those little tubes that are joined together, right? There's 1, 2, 3, 4, 5, I think 6 of them all together. And it's called the Polywell reactor. And this is a hydrogen reactor, and it uses boron fuel. It's completely safe, non-toxic, no hazardous radiation given off. Okay, and the interesting part is the boron is found in borax, and it goes on to tell how the actual reaction that occurs and the byproducts are helium, which is similar to processes that Keshe talks about in the Keshe reactor, the original rotating Keshe reactor, right? So this is interesting. It shows the boron there. It mentions when the boron and boron nucleus and the proton turn into 3 helium nuclei, a small amount of mass is lost. The mass turns into 0.0000, etc., 0.15 joules of energy, which doesn't sound like much, but this amount of energy becomes quite significant when we consider how many boron atoms there are in just 2 teaspoons of boron. I think they mean 2 teaspoons of borax. Okay, so 1 plus 1, 2 is 6.02 times 10 to the 23rd atoms. Actually, they may mean boron itself here, but borax has about 20% boron or something like that. So they find the energy contained in these 2 teaspoons of boron, work it all out, 9 times 10 to the 11th joules. And that is enough energy to send an F-16 fighter completely loaded with fuel and weapons to the moon. It's enough to escape Earth's gravity and go to the moon, basically, from 2 teaspoons of boron. All right, so that's kind of an interesting statistic. And this nuclear reactor, this boron or Polywell reactor, is one way that this energy can be released. And it goes on to say it's completely safe. They have these stainless steel donuts, they call them. These are basically tubes, and they have copper wire inside. And I thought, well, isn't that interesting? Because in the latest workshops, that's what we were talking about, these tubes. And so, this site goes on to say more about the magnetic field. The coils create about 2 Tesla inside and so on, and create these beams, which the magnetic field accumulates the electrons at the center of the cube, and these negative electrons create what's called a potential well. That's why they got the name Polywell. So what happens with this negative cloud at the center, it also brings in the boron, hydrogen, and boron and hydrogen ions, the protons, to the center as well. They get attracted. And then when they collide, a nuclear reaction occurs. So and you end up with a 2.46 million electron volts, basically, and there's a metal collector that surrounds the whole thing that collects the alpha particles that are given off by it, and it slows them down enough to recover them, apparently. So it's not really, because alpha particles You're just using, no, because alpha particles only travel a few inches in air, and they tend to they can be stopped by your skin and so on. You don't want them inside your body, but they don't travel very far in air. They tend to just die right out. Right, and then you charge the collector to 1.22 million volts, and that slows down the alphas. And so we're talking about a large unit here. This is something that's 3 meters across, basically. And so you're talking about powering the city of Port Angeles, Washington, for example. Um, basically, the idea is that, well, what I did, maybe I can show here. Get back to my other. Oops, I don't know if that's going to work properly. No, it didn't. Okay. Yeah, you can see that shared screen. It doesn't highlight it here. So maybe if I, let me, oh, okay. Let me try it again. Sorry. All right, let's try that again. Okay, that should be working. So, where was it here? Let me just see. No, I'm missing it. It's the other way. Hang on just a second here. I'm gonna have to do this a little differently. And go back into my pictures for a second and find the correct picture. There we go. And back to sharing. It's hard to do live stream and the Zoom at once. They're both two different technologies. Okay, you can see this picture here. It's just a bottle with the borax. I take the borax crystals. It's just a white powder, and mix it up with some boiling water till I pretty much can't mix any more of the borax in. It's a pretty thick solution. Then I let it cool and pour it into this jar. And then I put a nano-coated 14 gauge copper wire in the center. Had it suspended by the cap of the bottle. And overnight, these crystals formed. So, whoops, you can see the crystals, stay still. You can see the crystals around the wire, around the nano-coated wire. So I thought, wow, that's interesting. Instead of having a quartz crystal and drilling it out and putting your GaNs and nano-coated wire inside, why not have a GaNs coated nano-coated wire and grow the crystal around it instead? So that's kind of the idea here, to experiment with. It could be a source, or it could be a way of extracting or transmitting energy from the wire as well. Like when the wire is electrified, what happens to the fields? What happens to the nano coating and the plasma that's in the? We're getting some microphone knocking around sound here. I think it's Robert. Okay, so anyway. In this case, the wire has, let me see, what did I put on? I don't think this one has any GANs on it, just the straight nano-coated. And I wanted to experiment with a couple of different, different situations with wire, nano-coated wire. What if it had, for example, the one I really want to play with is the copper nano-coated wire coated with the copper GANs, and then the copper crystals as well. You can have blue copper sulfate or other types of copper crystals that are very beautiful that could be grown, and that way it keeps it all copper based. And surely there would be transition there between the I'm looking at the interface between the actual nano-coated wire and the crystal. I'm interested in that. I'd like to explore that more, see if that can be worked with. Right. That's definitely one idea. I've got it. I've done that with some of the other setups I have. I haven't really done it with this wire yet. It's still in the growing process. I'm still working with it in another setup right now. But yeah, it's quite interesting. I like the layering effect of it, and you can see that's another one. It's not quite so clear. Starting to. No, it's quite hard actually. It's like a hard crystal. Yeah, it's not soft at all. This is another experiment where it's taking the same crystals and just put some food coloring in. It looks like copper sulfate crystals, but these are just the borax. Nice thing about borax is it's not toxic as well. You can play with it and not hurt yourself. This is the starting of the formation of the crystals in that setup. I was trying to encourage it to grow larger crystals is what I was interested in. You see how larger crystals start to form. And what you can do is that you can actually farm the crystals. Like you can pick out the larger ones and use those as the seed crystals for your next growth that you want to do, or another growth of it. And I tried to get, I sprayed some, I've got these coils, these big, this is 3/8 copper, copper coils, and I had them nano-coated more or less. It wasn't a good nano-coating. I was experimenting with fire and trying heating in the oven, that kind of thing. So I also sprayed them with some of the this stuff, the borax solution, and I put some in this container as well. And you can see originally in the container, this is after a couple of days, it started to kind of crack and bubble up because it was quite flat originally. And then it starts bubbling up and cracking and sort of, you could actually hear it. I'd be sitting here by my desk and I have it close by. It's crack. A couple of minutes later, a little crack. Where's that noise coming from? And sure enough, when I listened closely, and then my crystal, which I had set up, had fallen over, and this stuff, the crystal underneath that was growing started pushing itself around, and it actually knocked over the crystal as it was growing and bubbling up. This is after a couple of days. Yes, yes, these are hollow hollow tubes. Yeah, I had them originally as a way to have as sort of an induction coil around another setup, and I could put power into them and had pulse DC going in and this kind of thing, trying to stimulate different things. I've got some other plans for them as well. Coils into globes or balls. I'm not. Let me get back to. Okay, let me highlight you there. Uh, right, nice. Okay, so that's you have a similar shaped coil inside of that coil, right? I can't hear you there, John. I'm not getting audio, so.
You would like to have a spherical coil.
Okay, I think I understand what you mean.
Because right now people are experimenting with setting the inner coil on a 45 with the outer coil. I think you could also experiment with a spherical coil like you've done there. That would be the inside wire of the coil, and then you would twist wire around that inside wire before you turned it into a ball.
Well, if you notice, there's a second one inside,
Yes.
and the idea was, well, when it was discussed, was that is your magnetic and gravitational, are these
Right.
two wires. And what it occurred to me, it wasn't actually described this way, but it seems that this would be like a plasma trap,
I
where
think so.
Right,
it would collect
exactly.
plasma in the center of that inner ball, and it would stay there. It wouldn't leak out, depending upon how tight your coils are.
Are they both wound the same direction? Those ones? They're both.
I believe so. Yes. This
Right.
was just, I was just experimenting. Just this is a piece of art. I hadn't intended to use it for anything, and then it came up that we should be making these and experimenting with them, and I thought, interesting.
Yeah.
I mean, this is
That's basically the way that they do trap plasma in a magnetic field. For example, they have what's called a positron plasma trap, and it uses the angle of that taper at each end of your coil there. At a certain angle, basically the positive charged electrons, the positrons, can't get out because they just bounce around in there. They cannot exit the ends because of that taper and the fields that are in there. So, yep, they just bounce around and hang out with each other. And you can actually have a positron, which is antimatter, what we call antimatter, or the scientists do, and keep that plasma inside that field they've done it for up to days at a time, with no other external voltages or anything else to maintain the plasma. It just rotates in there on its own and is quite happy as long as it doesn't bounce up against the walls and annihilate itself.
Rick, because I'm having a difficulty explaining what I'm trying to put across. Can I share screen and
Absolutely, please do.
Can you coach me through how to?
You want to do the annotation on a white screen? Okay,
Yeah,
sure. Let's do that.
Let me see. I do share screen. I thought I was doing that. No, I did it wrong.
No, it started. Now we have your whole screen, though. You probably don't want that.
Any of that.
Okay, we'll stop this screen sharing.
Well, I'm seeing how I'm going to do that. Okay. What I really want to do is the annotate.
Okay, so
and all I want to do is say that before you twist the wire into this ball, put coils around it. And so when you twisted it, the wire into the sphere, you've got a spherical coil.
Could you, I think you could probably show that. What you do, Denny, is you go to your share screen and there should be whiteboard there, and select whiteboard instead of your desktop. Whiteboard.
I think I'm clicking on whiteboard, but since I'm going to do share screen again.
Yeah, share screen, and that should bring up a bunch of things.
There you go.
Okay, now I'm just going to.
I think I just. Okay, I might have interfered.
Okay, so here's what I'm going to do. He's made the spherical egg. Let's just say that he made an egg with one wire. Okay. And he made it around here. And what he really did was he made the sphere going, he made a spiral going this way, and then he made a spiral going this way, and then he flipped them when they were equal. He pushed them together in such a way that it made an egg, a ball, a sphere. And so what I am suggesting, before he makes the sphere, he coils the wire around he coils another wire around. So you get the idea of what I'm saying here, right?
Right. Mm-hmm.
And then he turns it into a spiral with this coil around it.
Mm-hmm. Yeah, I've been thinking
the same thing. And then forms it into this sphere.
Right.
With coils around it.
Yeah, yeah.
Well, I just can't draw it very good, but I'm trying to get the idea.
Yeah, we got the idea.
So the idea gets across.
Yeah. What effect do you expect to see from this?
I expect to put, and also put another one around this.
Mm-hmm.
I expect to increase the plasmatic power.
Mm-hmm.
What I have in mind, and I'm hoping to get Robert to do some designing, is I would like to put one here, one here, one here, make a star formation out of it. Underneath here comes a spherical plasma battery. Underneath here is a spherical plasma battery, and these are the call them spherical coils for lack of a better name. This thing here is what I'm trying to do. This here this represents that. Okay, it's one of these.
Wait a minute. What'd you say? A spherical plasma battery that you just kind of dropped in that term?
Well,
what's that now? Is that your
plasma battery down here, which is it's like one of the stacker units, but it's a battery. It's been made up to be a battery. In other words, you've got
a coil and so on, but it's you mean a coil, but it's in a spiral?
Yeah. Right down here. Okay, I'm
This is Robert Stubblefield. I sent the other Robert a photo of one that I made, if that helps any.
Okay.
Yeah, spherical batteries.
I've got a echo from my side. I wonder what I'm doing wrong.
No, it's not your side. It came in from Robert Stubblefield.
Okay, So this looks pretty obnoxious what I'm drawing here, but this is what I'm saying, a double,
Okay.
I don't know if I can write this right, a double, D-O-U-B-L-E, coil, double spherical. I guess I forgot my P.
That's close enough.
Spherical coil.
We read gibberish.
And they're set in a star formation. Underneath these, on the base, these double spherical coils, sets a coiled plasma battery. Okay. Underneath these three, a coiled plasma battery. We were talking about a coiled plasma battery last discussion last week.
Right.
And these particular connectors that run from each plasma coil, double coil, is they could be the double capacitors, the split capacitors. Each one of these could. Not only do they act like the split capacitors, they hold the star formation together.
Mm-hmm.
So I'm taking the idea of the two stacker coils, the inside and the outer side, and instead of stacking them this way, like 1, 2, 3, I'm putting them in a star formation, and instead of using one row of coils like was described in this model. Can you understand what this model is? I'll explain it again. It's two of the stacker coils perpendicular to one another. The inside going this way and the larger outside going vertical, the inside going horizontal. But instead of doing that, take these things and turn them into a double spherical coil or ball, a double spherical coil, like I'm trying to explain.
Okay, Danny, would one coil in your double spherical coil, would one coil be going in one direction and the other 90 degrees to it, like in the double coil that we just saw there?
The difficulty I have in that is that I can't get my wires out easy enough. I'm running across into my coils if I turn them. So I'm trying to get my wires out that will feed into the battery and into the split capacitor, so that if I can get them out, I might be able to get away with just a single spherical coil and don't have to worry about the double, because a sphere has like you were talking about, the containment of the plasma, and it has this sphere has a magnetic quality to it as well, not only a gravitational quality, but
what if
yes, go ahead.
Okay, I'm just
I didn't expect to put all this out. I was going to make one first. Of course, you can make it with a lot lighter than 14 gauge just for a prototype. You could go down to 22, and since I'm blabbing here, I tried to price plastic tubing. It was comparative to wire, and so I thought, well, maybe I'm I haven't done enough research. I need to do a little deeper looking for the price of plastic tubing. And then I thought, well, he was talking while you could, Mr. Keshe was talking while you could use a hair. So when I went to plastic tubing, I just said, well, I could use fishing line, monofilament, maybe larger, to act as a substitute for wire as well. And that's fairly cheap for plastic.
Aquarium tubing as well is not too expensive.
Not too, it's silicone.
Yeah, I don't know if I'm thinking about this right, but it almost seems like this is a step backwards, back to the ping pong ball idea.
Well, it's a coil. I'm not spinning anything. It's in a star formation. I also thought, well, and I purchased some crystal balls, some what's that called?
Quartz?
Quartz crystal balls that would go inside of these. So I purchased them. So when I made one prototype, I could put a crystal ball. And so what I was thinking that since Rick is making crystals, and the crystals that are following right along and leaving a hollow nature around some of his coils, that he could make a spherical coil like who is it? KF. Who is it? John?
Who, me?
Yeah. I mean, not the other John. Who we got? The guy that had the coil.
That's
John.
KF John. Yeah.
KF John. So Rick could make his, or anybody could. Now Rick has disclosed how to do it. We could make crystals around a coil, and I was just adding a double coil. I mean, take that wire before you twist it into this spiral.
Excuse me, I have a comment later. Later, I comment about the winding crystals. I found a note here. Later, I can share it with you. Sorry, continue.
Okay. I'm not trying to take up time here. I'm trying to get out of this drawing and out of this explanation faster than I'm not.
No, it's all good.
I want to get out of it. I want to be able to express myself, and I'm having a little difficult time. It's
the star
formation.
You can understand what occurred to me. Let me just throw something in quick before I forget about it. When you drew that left side picture here, it occurred to me that you drew a circle around the whole enclosure, but I was thinking, well, if the tube was actually in that shape, if you had a tube around and then suspended your other coil in between the tube, essentially you would have it similar to that other drawing on the left there.
Yeah.
You would have the two criteria in a way, the inner and the outer two fields. You want the two what would you call them? They're not
magnetical and gravitational.
Yeah, essentially. I used to think that they were two interfering magnetic fields, but they aren't really. They're at cross to each other, but they're not. They're like separate fields essentially. They're layers.
The reason I went to a spherical coil was I was just trying to multiply this effect in my mind's eye. How could I multiply this effect?
I was thinking the same thing over the last few days. And of course, one way to do it is you add another third coil into the mix. So that way you have 3 dimensions, 3 different axes that are controlled, basically. And if you think of each of these coils, usually when you have a coil, or some, there we go, or a donut, let's say, and there's some sort of energy, either a superconductor or whatever, then the fields tend to go through that coil, sort of they're sort of like that sort of thing. It's a focusing and controlling apparatus. So if you have one direction and then the other direction and the other direction, you'd think you'd be able to control all three directions. And it starts to look like the old insignia for the radioactivity and so on, which is the atom and all of that. And it's funny because in the last few days I've been sort of dreaming about all this and daydreaming about it and so on. And today I was at the coffee shop and just staring out the window, and the last couple of days I've been thinking about this, and what it is this car pulls up and it's a Toyota. And I don't know if you're familiar with the Toyota emblem, but
Yeah,
it's basically it's a circle, and then there's a hoop at the
Yeah,
top.
that's a T. It stands for a T. It's got the circle.
Well, wait a minute here. Wait a minute. Not the
All
way
right,
I'm
sorry.
looking at it. I'm looking at these as tubes. Okay. I'm looking at that's the top tube.
Yeah.
And then there's another tube that they show that's inside the other ones. Like that kind of. They show it as connected, but if you look at it as it being inside, so you have a top tube, you have an inside tube, like the two on that we see on the left that you drew there, Danny. Just exactly the same as those two. And then there's a tube around those two, just like you drew in the other one over here. So in effect, the Toyota emblem combines all three of those fields, that horizontal, that vertical, and this all-enclosing one. And it's funny when I looked up the emblem because I got interested in this. Wow, what is this strange coincidence? Is it my mind making up things? And it is in a way, but it turns out when you look up the Toyota emblem, there's an actual website about it and so on. They mention that central part, that's the heart. Okay, they call that the heart. That's the heart of their customers, right? And the center of that is empty. That's voidness in the center. There's nothing in the center of that emblem, the very center of it. But that's the heart of their customers. The top hoop, that's the heart of their company, the company, basically, that encloses or works with the customers. And the big circle is just the overall, the whole world, like, is included in their vision of their customer at the center of their company. Is the most important thing, is this heart of their customer, and so on. And I thought that was actually quite appropriate in terms of the way we interpret the core of our reactors, the principality, this essence, and relating that to our soul, and how it's related to the emotional part of the body and that kind of thing. And it sort of all ties together. So that's why I'm starting to work with tubes more. I think tubes are good. And I like this idea that you just brought up here, Denny, which I've also got in mind with the tubes that I have, to basically, if you're to look at the Toyota emblem here, to wrap the tubing and basically that's your control system. Everything would be nano-coated, so it doesn't interfere with the plasma field, and yet you can control the magnetics and in effect the gravitational through the rotation of the plasma as well. So you have a three a 3-axis control system, essentially, with 6 wires, by sort of the way it looks at it. Or you could make it in terms of split capacitors. If this was one of your coils, you can end up having something that might come off of here and another one come off of here, maybe another one off of here and another one off of here, and so on. You can work with a coil like that, because if it actually becomes superconducting, then you've got something that you can draw off of or add to relatively easily. Anyway, I didn't mean to go ranting, raving there all over your picture Danny, but
that's what we want.
this is brainstorming, so
wanted to add a couple other things to it too. Is you might as well put your plasma, your plasma paste in a sphere inside of it as well, to test that out. I had my split capacitors have a center. It is made up of a tube, since I purchased the tube for that. I have some small tubing in order to first put a small tube and then put the coils around it. Yeah, they could be tubular, but it depends on the length of what it's going to need, because I don't have that much capillary tubing at this particular juncture, so I may have to limit. My prototype may have to be a little bit smaller than I want. What I'm looking for is a star formation that I can control too, but I'm also wanting to control it mentally. I want to be able to, so I'm setting a star formation. I have the energy feed to it, and now I've got the plasma flow. I've created my free plasma. See, I'm trying to get a free plasma ball here and a free plasma ball inside here and here in each one of them. That's why. There's someone there?
Oh, it's just my dog's mad at me because I'm not paying attention to him.
Okay. I thought somebody's trying to start a Model T Ford.
He's a big dog.
And so that's what I'm looking. My whole point is still looking for lift. This is not to generate electricity or anything or power a house. I'm trying to create a spaceship lift and control, and that's why get me off of here. Let me too. I hit stop share. Let me get off of there.
I was hoping Ali would be in today.
He was with the plasma coils, right? I mean the plastic system, wasn't he? Is that Ollie?
No, he's got a copper system. But
I know.
He's on the forefront of making an actual tangible shell field right in his living room.
Yes.
And I'm very curious as to how he's coming along with that.
I think he put up a design where he turned his coils perpendicular and stacked them, and
that filled his entire house and down the hallway of his apartment. He couldn't find the limits of the field from when he did that.
Okay.
Rick, it's Robert. Avetizian. I have something that Rick Stubblefield sent me for a plasma battery. I I can maybe show it, and he can explain.
I just realized my mic was off in the live stream.
Yeah,
Sorry about
have
that.
it downloaded now too if you guys wanted to see it.
Oh, cool. Look
After
at that. Exactly what I was thinking about. Where'd it go? That was
Oh, this
elusive.
one.
Ah, yeah.
Yeah, I made this while you were talking about it.
Oh, thank you. Very nice. Yes.
It's a spherical octahedron. You know, if you can make these curved edges straight, it'll become an octahedron. So this is
Right.
the spherical form of it.
That's a good point, Robert. I've been thinking about sacred geometry and how we can use it in this technology as well. So that's a good point.
Boy, that looks nice. I don't know how we'd make it. It might have to be 3D printed. If it was all in hollow tubing, that would be really nice, but hard to do. How do you make the joints so they all fit together?
Let me show you what Robert sent. And Robert, maybe you can explain how you define this as a plasma battery.
Yeah, it's not yet. Of course, there's no GANs or anything on it yet, but I just got it nano coated now. And to me, this is what we were talking about last time, the 3 coils, the 2 coils and a wire going through the center. Is that about what we were talking about last time? I'm just trying to put something together off what we were talking about then.
Well, what you're describing is the core of the latest reactor design.
No. I'm in the last plasma meeting.
Yeah, our man brought up the idea of a plasma battery, and actually, when I met up with him over the weekend, what he explained to me was you could create a plasma battery by something like this, concentric coils, and then you would tap into the center and one of the other coils around it, or a couple of them together, or all 3 of them together in the center one, and that would be like a plasma battery. But I was hoping he would join to explain further, but I'm not seeing him in the
Well, we know that
participant.
generally the center pin is the negative, sort of the way I understand it. Is that the way others understand it?
Yeah, sort of. It's the gravitational. But I guess when you tap into it, these curved ends would be uncurved, so the plasma would flow out of it. The bottom ones would be turned on themselves, but the tap
Well,
ones, whichever one you want to tap into, you would open it up.
yeah, I think like for example, the outer coil is probably it could be for picking up, but it might be for or at least the inner coil, that green one, would be for putting some kind of energy into in order to squeeze the plasma, or at least one of the coils would be used for that. Maybe the purple one.
Well, it strikes me that you would connect the green and the red as feedback. So there's a constant flow between the green and the red, and your output would be the purple. Does that make sense to anybody?
Yeah, he mentioned that you need a feedback to keep the battery in a charged state.
Yeah,
Mhm.
a constant flow within.
So there would be GANs and paper in between the center electrode and the green.
Yes, I think that's how I understood it.
I think the paper is just a convenience. If this was a sealed system, it could just be in a bath of GANs.
Right, probably. Okay. What
You
about
also mentioned
what about
you could.
Robert? How come the coils are, in a sense, backwards compared to the counter rotated one? Or they, I hate to use the word counter clockwise and clockwise, but these are counter wound, you could say, compared to most of the coils we're told should be clockwise wound. Is that deliberate, or is that just the way these worked out? Or
Well, when I make them, I made these today. I was in a rush, so I didn't pay attention to the direction of the winding. But to me, the direction of winding, it sort of twists the flow, but as far as the direction of flow from two, I'm thinking it would go from higher potential to a lower potential. So it, for me, at this point, I'm still not convinced that clockwise or counterclockwise makes any difference.
yeah, true.
To me, it's more potential difference
In terms of a induction
between the two
coil,
ends. But I may be wrong, so I still need to clarify that.
yeah, I'd rather see them all clockwise so that people don't get freaked out and say, "Oh, how come these ones are counterclockwise? We were told they all should be clockwise," and so on. And then you have to get into a description of what is clockwise, what is counterclockwise, and how do we, et cetera, et cetera. But I think you're right. I don't think it matters that much in terms of a magnetic induction and coils. Well, it's like you say, it's the gradient that makes the difference from one end to the other, not the whether it's clockwise or counterclockwise windings. As far as I know, it creates a field either way.
Going back to the 94th Knowledge Seekers Workshop, in the background, Mr. Keshe had a coil, a single coil with looked like 4 capacitors tied together to it. And I'm wondering if that was potentially what we're thinking of is the plasma batteries, or it could be used like a battery.
Well, definitely, I think, like, for example, well, if you go back to that other picture briefly, one of these wires, the purple, the red, or the green, I would think should be wrapped around the blue wire as a pickup coil, let's say, to put power back into it.
Let me get a snapshot of this. Let me see which way. Right there, maybe.
To me, that Sandor said that there was a purpose for each way of winding the coils.
Well, there is the idea that there's the entry and exit to a wound wire system. So before you put any potential into it, it's already, according to the way it's drawn, it already has a in and out is kind of the idea. So it would make sense to take advantage of that natural way the plasma would flow rather than trying to work against it by putting a potential across that maybe going the other way and making the unit less efficient, perhaps. As Mr. Keshe mentioned, that you could use coils that go one way or coils that go the other way. As long as you keep them all the same direction, then it should work. What the correct, so-called correct way, the normal thread, I call it, type winding, right-hand thread, seems to be the way that's preferred for the maximum efficiency. Okay, so now you're.
I'm trying to draw, or I mean, you guys can use the whiteboard and mark up on it if you want to show something.
No, that's essentially what I was speaking of. Yeah, something like that. So.
Yeah, Armin also mentioned that you could use cylinders.
Yeah, I was just going to mention that. In
as
fact, I picked up some different sized copper pipe recently to play with that.
Yeah, I was starting to model that, but
Oh yeah,
didn't finish it. Yeah.
yeah, that would be an interesting set of fields going on with this series of concentric pipes, essentially. And then if there was wiring, coils in there too with the pipe.
Hi guys, this is Narek from Los Angeles.
Narek? Oh,
Hi,
okay.
yes, hi.
Hi.
How are you guys?
Good.
I had an idea for amplifying the fields. I don't know if this is a good idea or not, but I was thinking about making the coils longer and then making the coils into a coil. Does that make sense? And then making the coils into a coil itself.
That would require a lot of copper.
Yeah, that's what I'm thinking. So it's going to be used for flying, for whatever we're trying to do.
Yeah, I think you'd probably run into issues with that because you'd have equivalent fields interacting at 90 degrees to one another instead of having the opposite direction or the opposite vector fields interacting at that rate.
Wouldn't 90 degrees be good though? In a way, isn't that what those the two loops that we were looking at that intersect at 90 degrees? Wouldn't that be the way those fields would go? Even though they're the same kind of fields, they're interacting at 90 degrees. This is a big question to me.
The difference would be, Rick, the inner loop. I'm going to call it a loop instead of a coil, just to keep it easy. The inner loop is going to be primarily gravitational, which is going to be one vector, and the outer loop is going to be primarily magnetical, which will be the opposite vector. So if they're at 90 degrees to one another, they're not going to be colliding. They're not going to be creating an interference pattern. If you have equivalent vectors intersecting at 90 degrees, like you would if you had a coil wound into a coil, you're going to wind up with interference patterns within that field structure. Or at least that's what it seems like to me anyway.
Do you want interference patterns or not?
Well, one of the things, if you wind your coils, if you have one of your coils wound backwards, you're going to be introducing interference patterns within that system. And that, as we know, that's going to drop your efficiency dramatically. It's going to create a potential, not necessarily a barrier, but an inhibition to the field flow.
Right, unless we want the interaction, if we want the what you call it, the overlapping of the fields to create maybe new materials or to create a special effect where they intersect.
Yeah, certainly. I'm sure there's probably a reason to do it that way. But
I've had this thing. I've had this thing all my life of counter-rotating magnetic fields are the most important thing. And this has plagued me since my childhood, essentially, and is the main reason why I've gone through a lot of the crap in my life. Is what is it about these counter-rotating magnetic fields? But in the last couple of weeks or so, I'm thinking it's not counter-rotating magnetic fields, which indicates they're against each other. They're actually not co-rotating. What do you call it when they're at angle?
Perpendicular?
Yeah. Not counter, not co, but oh, geez, I had it last week, the right term for it, but I can't remember right now.
Yeah, your description brings up the machine from Contact, that Jodie Foster movie, where you've got the three rings. Each one is spinning. Each one is creating a dynamic magnetic field, but they're interacting at 90 degrees to one another.
Mm-hmm.
Yeah,
I didn't see that movie. Maybe I should. So
you
get
should. It's a
clear.
good movie.
It is. It's a really good movie.
Yeah.
And yes, I can certainly see there'd be a purpose for that. And the idea was to create a barrier between one reality to another.
Mm-hmm.
In
Yeah.
the movie, anyway.
Yeah,
that was the concept
that's
of
right.
the movie.
That's exactly right. As we could see also with Ali's video he's shown recently with his reactor setup and his maggrav power unit, his starship formation. I don't know if everybody's seen that video. It's quite amazing in a way. He says he can see shimmering fields and actually see lights forming and this kind of thing. You see on the video, in one of his videos about that. It's hasn't been released yet, but there's actual his feeling of it when his reactor is running. The feeling of it is it draws him in like it's a different dimension, a whole different world, and that's where these fields seem to come in, where I think that if we have two, not counter-rotating, but what is the word? Jeez, think about that.
Contra-rotating? Is that the word you're looking for?
No, not contra or counter. It's not co or contra. I just can't place it right now. It'll come to me later, I guess.
Oh, come on, Rick. You're the only one that's gone to school for this.
Conjoined?
That's close, but no. Oh, I know. It's cross-rotating.
Right.
They're at cross to each other. Same as what we're seeing right now. These are crossing. So we have, now if those were magnetic fields, they wouldn't even feel each other in a way. They wouldn't, when they cross at 90 degrees, they don't interfere with each other is the way I understand it. But when they cross at other angles, then they will, depending on where they interfere and so on, how big the fields are and whether they're tuned to all appear at the same time and space and so on. With Ali, for example, they were doing tests on how far the field was from his unit, from his power unit, and using a magnetic field detector to see just how far the field extends. It seemed to extend out, 30 meters or something like that, at least down a hallway. So, yes, cross-rotating. I think that is to me now, this is the big news, the big new keyword for me is cross-rotate. I'm going to write that down so I can remember. All these great ideas, you can never remember them when you try to come up with them later. What was that great idea we had? That multi-million-dollar idea we can't remember. So cross-rotating, not even magnetic maggrav fields.
And I think even with these new ideas, we need to keep in mind the basic concepts of the natural systems. where the magnetic aspect of the fields, the expansion or the expansion part of the fields is primarily on the equator, and the contraction part of the fields is primarily on the axis. So you need to keep in mind where your axis is going to be on these things, because if you set your system up sideways, you're going to have a really narrow, really tall spaceship.
That's where the pinheads come from.
Yeah.
Well, yeah, that's a good point. The axis, yes. So, again, this gets back to the idea of actually planning one's project in terms of plasma planning before the planning of the physicality part. So you notate where the flows are going and what you want the plasma to do before even thinking about how to do it in terms of the physical parameters and so on.
Yeah.
This is
Yeah, because
something
there's
that,
lots of people coming up with ideas, and like they look really nice. Some of the artwork that I've seen is amazing, but when you look at, try to imagine how the plasma is going to flow, you can see it's running into each other, and you got
yes, like,
spikes in certain areas and dead
yeah,
spots in
yeah.
other areas.
I've seen some beautiful pictures recently of these reactors, these 3D drawing reactors, all shiny copper and so on, not nano-coated, but from I forget the site. There's a group that works with new age stuff and so on, and beautiful looking, 3D representations. But when you really look at it, you think, well, if I was a plasma and all that shiny copper is just getting in the way and sucking all my energy and making me go off in directions that I don't want to go to. So I'm thinking, that's not going to work.
Yeah,
That's a nice looking
something,
saucer. I want
yeah,
one.
something else that comes to mind just while I was watching this drawing be created here is we're not really sure how the interaction of the multiple fields actually works too. I mean, we've got 3 reactors on the base with one up near the point of the spaceship, and it creates a round saucer shaped ship. How does that equate to 3 spheres interacting with one another? It's just a little weirdness that I'm trying to wrap my head around.
Well, the idea is that the 4 spheres create the free plasma in the center. So if you have a free plasma there, and then you create, say, a dozen other free plasmas in different places, then they can interact to form the actual crusty part of the craft, you might say, the formation, the skin. That's the way I
Yeah, but if you
understand
look
it.
at the interference of 4 spheres placed in that situation, what you have is a kind of a modified tetrahedron. It's not going to
Mm-hmm.
be a circle.
No, but the
So
circle
there
part
has to be some kind of deformation of the fields as they interact.
yes, well that's where the 4th reactor can push and pull and create other than a spherical free plasma.
Robert, you're just having fun now. He's just showing off.
Hi guys, it's Modris.
Hi, Modris.
I was working on some ideas and I was like, sure, maybe there is some value or your opinion. Can I share the screen?
I don't know. We're really liking this flying saucer thing here. Okay, we'll have to get back to that, Mr. Robert. Okay, we've got a different. Okay, there we go.
So one of the things I was thinking, like if we create the triangle and we do the smaller coil, like the normal with Mr. Keshe showed with this way, yes, and then we make another one and a bit bigger and the same thing, and then another one a bit even bigger, and we can use the golden ratio, the winding.
Mm-hmm. Yep.
Basically, it can be extended to the point when you go here to the same way, and basically then you create the 120 degree the way how the coils is positioned. And I remember Mr. Keshe was saying like it's quite important, not quite important, but it's have good beneficial if they are positioned in 120 degrees. What he mentioned, that's why the fat boy is good, because the coils or the reactors is on angle. So this is one thing, and another thing
That's
what
a
I
good
was
point.
thinking. Sorry.
That's a good point. I like that concept. I think that would tend to trap the free plasma in the center, or at least focus it in the center with that system.
Exactly, because even remember like when he's saying like you can use different type of materials, but if we don't use the different type of materials, but we do it like like in a growing ratio, so this would do the effect as well.
Mm-hmm.
So another thing just about the coil itself. So if we wind, let's say this is the gravitational, the inner coil, yeah, where we have the wire which goes through in the end. For example, this is the coil. So I create another coil instead of to going like that through and coming out here. What I did, I created smaller one, the same amount of twists. Instead of go straight through, I made it the same, let's say 145, 41, sorry, 144 twists. So like that, it's not going anymore straight. It's still increasing the strength because it's been twisted. So each twist, it's interact with each other. I don't know how it will affect because you have another one. Maybe it's will be too much, but I think it's the way how you can still have the same coil, but make it stronger. It's like you have 3 in, not 2. What's your opinion on that?
I think you're still going to wind up with a tube of plasma within that second inner coil that you need to collect. That's what strikes me as having the single wire that runs through the inside of the gravitational coil is that's actually collecting that tube of plasma that's being what's the word I'm looking for? Well, formed in the center of that helical structure.
Yeah, it seems to me like you just have a stronger gravitational field. Your gravitational field would be much stronger than your magnetic field.
Would it still be?
Outer one, you will make the same one, if you mean that.
So you'd wind up with 3 coils on each loop. So would the inner one become magnetical and the outer 2 become, or the inner one become gravitational and the outer 2 become magnetical at that point?
It's always, the inner one is always gravitational respect to the outer one.
Yep.
For example, here, this one is gravitational and this is magnetical, this one. And then you take another one you make and then it's again, this one respect to that one is gravitational. To the outer. I don't see much how it could interfere. I see it could just increase, but I was not sure. So I thought like maybe to do before to do a big job.
I liked your first idea more than your second.
Yeah.
I was thinking a single wire will tend to like radiate from the wire, from the center of the wire outwards, whereas a coiled wire will have a field inside the coil, but it may not be radiating out from that inner field the same way that a wire would.
I just myself like trying to look on the plasma, and somehow I feel like the plasma never goes straight. It's always going with this spin.
Well, that's a good point, and that brings up another bit of a topic in a way. In that, does the plasma want to go in a perfect circle, the way we make our flat coils, and the way tubes are made, and that kind of thing? You know, like a flat. Whoa! Big earthquake.
Yeah, you're correct, but Mr.
We
Keshe,
just had an earthquake here.
Yeah, wow.
Or something. Just shook the whole building. Wow. That's the biggest earthquake I've felt ever here.
In case run out.
Well.
So about the, I forgot.
It's totally forgot.
Were too strong. The earth moved.
Yeah, when the earth moves, it makes your mind forget about a lot of things, I'll tell you. Wow.
You know, there is an old say. It's a very crude way to put it. Says you never needed to go to toilet to forget that you're not in love, even when you stay next to your loved one. So the earthquake takes over.
Yeah.
Was it shaking or was it just a whack?
Well, there was a little sort of thump, and I thought, geez, maybe someone just came in the door or something. And then a few seconds after that, there was a good, like, shake, just about 3 seconds worth of back and forth shake, just enough to let you know this is not just blasting or something.
You heard the buck first?
Hey?
You heard a noise first?
I heard a little noise first, yeah, or felt a little, sort of almost like someone knocking at the door or thumping on the side of the house. And then everything had a good shake. And just for a few seconds here. I'll look it up. I wonder if it actually showed up yet on the earthquake site. Doesn't say anything.
It didn't get inland because I didn't feel anything here.
Yeah. Well, I don't know. It could have been a tornado coming by or something. Who knows these days? But something definitely occurred there. Okay, so anyway, let's carry on. Everything's good.
You know, maybe Mr. Keshe would like to explain that single coil setup that he had on the 90.
I'm not here today. I'm just listening. Enlighten yourselves. I'm a listener. I've been listening all the time. So I just dropped off because of the battery. I came back on again. I'm just a listener. Don't forget, it's my holidays. I need my brain to switch off.
Yeah, no kidding. Okay, well, let's carry on here. Where were we? We had the picture up there. We did have Salma had his hand up. I wondered if he had something he wanted to say or what the hand was up for. Maybe we should have said hello there.
Rick, after that, this is Robert. I can show you guys that battery that I had. It just came out of the costume. I just washed it, so I can show you now.
Okay.
Hello, Rick.
Hello?
Yeah, Salama here.
Oh, okay.
What I'm trying to talk is pre-stacker Maggraph. I have one DIY.
Mm-hmm. Do you want to show it?
No, I already shown it before.
Okay.
I achieved 80%.
How
Ooh,
much?
very nice.
80% reduction.
50%. Wow.
80, sorry, 80, 80.
Oh, 80%. Wow. Okay. And what kind of load are you talking about for that reduction? That's after it's
Oh,
already broken in and so on, you mean?
yeah. The load is not that good. It's 207 watts.
207?
207 watts. Because I haven't done my what you call it? Single coil. So I haven't load fully. So when I'm waiting for my coil to dry up, this is what I get. 80% reduction in 4 days.
Okay.
The meter reading that I get at 80% is not on the wall. The wall power meter, I don't get it from there. It's only it goes up and down, maybe 5 maximum or 5 minimum. So it's not on the wall. It's from the main power unit.
Okay.
So I don't have photos. Sorry, I don't have photos. What I got was from 400 down to 200 down to 40 what do you call it, watts per hour. So the next day I got 20, then the next day I got 10, and my last was 8.
And
So that 8 and 400, 8 and 40 is about 80, correct?
What are you using as a load on the unit?
Fans, lights, call that single reactor. Yeah, my old photos all shows all that, you know. I'm using it all over again. It's just like I'm waiting for my single coil, and I'm waiting to do all the improvement with the loop and all that. And this is what I got. I got 80%. And you must remember, Rick, that my system has been running from about 11th of November. Yeah, I showed you on this group
Yeah,
reactor.
I think we have seen that before.
So what I'm trying to say is that I got 80%, and everybody who does that will get the 80% or the 0, or I mean the 100% for sure.
Yeah, Salam, since it's been running so long, you should be just about ready to put full load on that thing.
Yeah, so that's what I got. I got 80%. So plasma maggraph unit works.
Right on.
And
Thank you.
My intention is that there's a lot of people who gave up when they only reach 14 days, 21 days. They just give up. But if they were to go ahead and just leave it or for a longer period, they will get the same thing. It's just the matter of time that the wire get nano coating, as Mr. Keshe say.
Did you hook up a single reactor too?
Yeah, single reactor. But my star formation reactor, I got it. It is on. I mean, inside my 3 stacker. Inside my 3 stacker, but it's not spinning. The single stacker is spinning.
Do you have a single unit as well as your stacker unit?
Yes, I got a single reactor. Sorry, I'm doing my single unit now because I'm having rain that I'm afraid it will dam the coil. So I'm taking a longer
Can
time.
you show us a picture of what you're talking?
It's very simple, Mr. Keshe. My respect to you, my utmost respect to you. But it is, and I just come in today to tell people you have to wait for the 2 months and the 3 months.
Yeah, but can you show us your setting, the way your system is set?
My system is when it's just the load before the 3 stacker. It's simple. It's very simple. It's do it yourself, and I don't want to show because I did it very crude. You know, it's very crude. The way I do it is very crude. I got to explain to you that I'm a layman. I never touch a voltmeter. I never touch a drill. What I've been doing all my life is office work.
Well, there's nothing wrong with crude, Salama. It would be a good example.
Very good. It is very crude, but I think Rick have a photo of it or something rather. We remember we showed when I told you that I had a 3 stacker running.
Yeah, I don't know. I've got photos stashed away. I can't find
and
something
also,
like that.
remember I told you that my wire was auto generated, nano coated. Remember?
Mm-hmm.
Yeah. So
yeah,
it's all simple.
Yeah.
Simple.
So you don't have a picture for us, so okay. So I don't know if I could find it. It's not in Facebook or anything. Yeah, you sent it separately, right?
Yeah, but it's very long ago. Rick. It's 11th of November. I just switch it around when the load is supposed to come before the 3 stacker. I just switch it around. That's all.
It would be really helpful if we could show systems that aren't really perfect, that aren't, the coils aren't all perfect and all perfectly spaced. And it would go a long ways to help with the inhibitions of some of the people who want to build them but don't think they have the skills.
You know the 3 stacker that I have now that I achieved the 80%?
I've never seen it.
It's okay. It's done by hand. I don't know how to use the drilling machine.
It would be awesome to be able to see that.
Yeah, and it is not like the perfect 144 or 81 or something like that. It's not perfect.
Okay. Well,
excellent.
does anyone have a unit they'd like to show? That would be nice.
Can you take a picture of it and send it to Rick?
Yeah, okay, that's no problem for sure. But the thing is that my intention today is to tell people it works. Just give it a longer time, duration, and you will get what is promised to you.
Yeah, but what'll be nice is to see how you done it. This is the whole purpose, to show how you've done it.
Yeah, but it's very simple, very crude. It's only
Doesn't matter. The crudeness doesn't count. It's to show that everybody can do it.
Everybody can do it. I assure
yeah, but
you.
we need. It'll be nice if you could send a picture, the way the way it is. That what do you call it? It can be done. And people can replicate it.
Yeah, we don't want to see perfect. We want to see the crude. We want to see the hand-wound coils and to show people that even that works really well.
It works. It really works. You know, after the day, yes, on the 29th, I went to do something different. I went into the house and looked at where my wires, where my nano coating might not be going. So I switched on that lights, you know, and it went up to 40. It went up to 40. And today, it went down to 20 again. It really works. The nano coating will goes right into all your house, all the wiring in your house, sorry. And it's just a matter of time. As long as you switch it on your first day and it's working, you just have to wait for it to spread the plasma or the nano coating all through your wire, and you will get it for sure.
Okay, well, you can send me a picture so we can have a look at it maybe, and then we can talk about it more. That would be nice. I see Lee Gordon Coates has his video on and a coil there. Do you want to speak about that,
Yeah, I've
Lee?
been playing around with some plastic weed whacker cable and basically that to see if I can make a coil out of it, and it is possible to do. It's a lot harder than doing copper coils, but this is like an 81 turn inner coil of one of the plates. That's didn't get the outer coil done, and it's easy to make. Splice in the plastic string, and just make a tight coil, make a Western Union splice, and it's really strong. You can't pull it apart. So I just thought I'd show you that, so that it is possible using weed whacker plastic cable.
Well, that's quite interesting. And if you were to think about it, it's very much like fiber optic cable or fiber optic tubing, which would
Can you show
carry
this
light.
again, please, Rick?
Let me spotlight it.
I just show us
There.
Yeah, okay.
So yeah, give us a good picture of it again there, and.
Okay, so this is it's a double coil. It's got the inner coil and then the outer coil. This has got 81 turns on it. It's I wrapped the plastic around the steel rod in the same way I would the copper, and then I got a heat torch and heated it up so it would maintain its the coiled shape. You can see this outer inner coil actually comes up nice and even and tight. This one's actually I've got to put on a piece of plastic tubing, but even without the plastic tubing, it's fairly consistent, fairly nice. But
and now when you
the
heat it,
the outer coil isn't very consistent. It's hard to get it to hold its shape, and it's very hard to keep like make 181 turns because it stretches and unwinds a bit and stuff like that. But it is possible. It's just a lot harder than doing it in copper. So, and then that's that Western Union splice on these two. You just wrap each one around each other, and it's really strong.
Did you use heat on that as well to make that splice?
Yeah. For this, had a piece of eighth inch steel wire, like spring steel wire, and I just, as I was heating the plastic, I was wrapping it around the spring steel. So, and then it forms a little tight coil on the end. Even wrap the ends back on itself at the end there. So,
I really like this way of connection.
Yeah.
Of the wires.
So anyway, I just.
What do you think of the one with the plastic tube in it?
What do I think?
I like the idea myself.
Well, I didn't know whether that, that single that single strand of copper wire in the middle was picking up a field, or whether we can delete that single strand going around there to hold it together and put a plastic tube in there. I didn't know. I don't know. I'm sort of, I guess you got to experiment, but I didn't know what would work better, or whatever. I suppose you could fill that plastic tube with Gantz or whatever, and have a little Gantz tube in the middle. But so anyway,
I think you can get that plastic tube to act like a coil, to be a plasmatic coil as well. I think you could actually put a single line of your weed whacker down through the coil of the tube as your gravitational portion, and the outside have the tube be the magnetical. That's what I think about it. Just run a single weed whacker wire down the center of that tube, nano coat the system, and I think you've got a magnetical and a gravitational system.
Okay.
That's what I think anyhow. Make it very simplified. I think you could also, if you can find a larger tube that will, this tube that you have, if you have another tube that would slide over this tube and run your monofilament, your weed whacker tube down the center, you've also got yourself a start of a stacker system.
Yeah, well, it's possible. I guess my conclusion is it's about maybe 10 times harder than working in copper. It's doable, but it's more difficult. So,
well, maybe I was also thinking of a fishing line, a heavier duty fishing line, that if you want to miniaturize the system.
Mm-hmm.
Yep, that's a good point. The fishing line is very similar to, and probably would work in terms of light. Light would pass through the line without much losses. It probably goes, right down the length of the fishing line without. You could probably, the same as a fiber optic cable or a fiber optic tube strand, I should say.
I think there's several styles and thicknesses of fishing line as well.
And you could also use actual, glass filaments. That might be useful to wrap around a core of some sort or tube. Again, if you had light traveling through the coil, actual light or photons or plasmatic light energy following the the confines of the coil, that could be interesting, I'm sure. We know that toroids will, especially if they're superconducting, basically it's light traveling around forever. So, or at least
I looked at a YouTube class by MIT on spherical coils, spherical, and I put that link in the chat, and how you get to, it creates its own inductance inside that sphere when you make a spherical, not so much a coil, but a sphere made of wire like KF John showed.
Mm-hmm.
But theirs is a really fine wire and a fairly larger ball. I'm still impressed with that idea as well. So I guess I'm gonna have to put my work where my mouth is.
Yeah, Lee, you should move your Visa card out of the picture.
Yeah, good idea.
I have.
What about if we use the coil with the cover, with the plastic cover, and then when we twist them together, we twist the part which is with plastic and the copper itself. So like that, we have the two materials in one. And when we depth in the GANs will cover the plastic parts, and when we're gonna run through the plasma, it will nano-coat the copper part. I think this could be quite interesting as well. And also, I remember that Mr. Keshe was saying like the property which gives when you use the covered copper is interesting. The field interaction. It's created a specific, and also the carbon structure. Remember last workshop he was also mentioning.
Yeah, that's why you would want to use plastic in part of your stacker system or other systems, so that you can have a lighter gradients. So your copper would be heavier than your plastic. So you're trying to get that hydrogen gradient in your stacker system.
It's instantly becoming like area way, because one is heavy and one is light outside, and it's already like one wire makes like infinity already, because there will be interaction between these two. This is how I'm see. I might be wrong.
Do you want to make a picture of what you're trying to? I'm not seeing what you envisioned there. Maybe you can do a screen share.
Yeah, I can do that. So the same thing what we do. So we use the wires, the copper wire, which, how you see my screen, it's horizontal or vertical? Okay, good. So we usually use the bare copper wire, right? So why we don't use it with the cover? The same wire, but it have the plastic cover. So you do your twisting as you do, but in the end, when you will twist them together, there will be some part which will be together with the cover. So when you will twist them together, you will twist the first plastic, and then you will twist the from the another wire, you will twist the copper. Yeah. So it's like that. You would have a, let's say it would be here would be another wire, which is inside with the copper. It's came clear, or it's still very not understandable? It's just everything what we do, just we don't remove the cover of the copper, and then we use plasma to nano-coat.
I see what you're saying. In a way, there's actually three layers. You've got your copper wire itself, which can be used as one physicality electron basis. And then you've got the nano coating on the wire, which could be another layer.
Carbon based.
And that'd be the copper nano coating on the wire itself. And then
it will be mixed with the carbon.
Right, somewhat. Plastic. Yeah. But like I've got a couple of pieces of wire that I nano coated one end, like you have on your picture there, and the nano coating is going right through the insulation, and within a couple of days, it's pretty much gone through a foot or two of insulation, and it's turned black inside the clear insulation. I can see it. So if you had those three layers, and like you say, the nano-coated plastic as a third layer, and when you twist them together, you're right. It's like you're twisting the plastic together as one layer, one coating, one plasmatic field, and then the nano coating could be twisted onto a nano coated wire. And then the copper wire could be twisted onto a copper wire as well. In a way, there's three different systems going on there, all within one wire.
The question is how to get nano-coated plastic. Would this nano-coat as well with the plasma, or we have to use the caustic to nano-coat at least the plastic cover?
Well, caustic has been used traditionally. Obviously, the torch method isn't going to work too well for that. Well, I shouldn't say that, because it could be the best way. It could be that once you melt the plastic and turn it into black carbon, and on top of the nano-coated copper wire, it could be the very best combination anyone's ever come up with.
Who knows? Yeah.
It could look really ugly, but it could be really beautiful on the inside, you might say. So. That's not a bad idea.
And it will become black anyway.
Just put the whole works in a high temperature oven and bake for 1 hour and serve.
I think even by torch, with going with the torch on it, you can create very quickly, burn it off, turn to the nanomaterials, and which instantly sticks to the copper wire.
Mm-hmm.
Yeah. So.
Yeah, you don't want to do that in your wife's oven, that's for sure.
True.
That would be a heck of a smell, and what a mess. But it's interesting because one of the ways they recover copper wire is to burn and melt the insulation off and so on. So maybe they're actually creating certain kinds of structures through that process, throwing it all away instead.
Rick, the Magrav craft is ready for takeoff.
All right, let's have a look. We definitely have to check that out. What we have to do there. Okay, yeah. What do we have here? Okay. Oh, it's out of view. It's gone.
Oh, that's cheating.
Oh, it's up in the sky. Lovely. Wow, it goes pretty good.
Where did it go?
It got away. Darn it. It went through the roof.
Has anybody seen it?
There it is. Seriously, you lost it. So what's the idea with the blue there? What's the blue indicate? Is that a window or some sort of just a coloration?
This is the front.
Okay.
I guess.
Racing stripes.
Yeah.
And did you have a particular vision with that form? What were you thinking of with the sort of organic look of it? Is it partly aerodynamic, I hesitate to ask?
Yeah, it just whatever came out as I was.
You have to sit on it and ride it.
Yeah, it looks like you could sit on it quite easily. It's got a yeah.
ride
You
it.
could see a little guy sitting
Yeah.
on there, and just
It's
yeah,
a jet,
it's like a
sort of like a
scooter.
jet ski. Jet.
I see now. Yeah, 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 yeah. The plasma motorcycle of the future, near future, hopefully.
I like it when it comes down on these lines on the pavement. It's not much wider than the line of the pavement, so you know it's little tiny mice inside there.
You should see the aliens that fly them. Yeah.
This is Hangar 7.
That's my lucky number. So I see there's a hole in the side of the door of the hangar. That's how we got out. Hey, isn't that a hole or what? Or is that just paint? It sure looks like a hole to me. I think he got out there.
I think it just parks up here on this column up here.
Right. No one will ever know where he is at night.
Off it goes.
Don't let Amazon see this. They'll want one. Because that would solve all their problems with their drone delivery system that they're rigging up for this year, which is the rotating blade phenomenon, which is not a good thing around kids and other birds and stuff like that. I like that. That's really nice. It's got a certain
I gotta
quality.
change the connections to.
The two plus and minus look like little antennas, kind of.
Work in progress.
Yeah, well, speaking of works in progress, in the chat, Alexi says that he's got a bit of an innovation he wants to share as well.
Okay. Okay, he says, I've devised a configuration of 4-way split capacitors that I want to share with everyone, and innovations if it seems good enough. Okay, do you want to show what you have there, Alexei? He says it's a configuration of feedbacks to boost the strength of the system with loopbacks between the 3 stacks. Okay.
Well, his mic's unmuted. I heard a little bit of noise, but
Yeah, sorry, I'm having trouble with my screen share here.
oh, there you are.
Okay, so do you have something? Oh, it started the screen sharing. So it says, there we go.
All right. Can you guys see that?
Yep.
Okay, so I've devised a simple kind of loopback system where the ends of, or the intermediary between each coil stack loops back into the previous, before the previous stack. So there's 4 different types here for different positions, which I'll show here. A sec. Don't mind the roughness of it. So essentially the way it goes, the last capacitor after the 3 stacks on the out portion feeds back to the beginning of all 3 stacks previous, and then the other ones also try to feed back into each other. And I position the inputs and outputs in a way such that it maximizes the amount of boost before it feeds back out. Yeah, just wanted to
One
share
being
that.
the bottom coil, 3 being the top.
That's correct, exactly. So it'll come in from on the left side and goes in and out.
You just lost your screen.
Yeah, I'm not sure what happened there. My computer's on the fritz now. Not sure what's going on. Sorry about that.
That's okay. It's recorded. We can go back.
Oh boy. There we go. All right. It's just my display drivers are all wonky on me. Sorry about that. All right. So yeah, any questions, or anyone think it's a good idea, or you think it'll work, won't work?
Just looking to decipher it still, and it looks very interesting.
I wonder if I could annotate maybe. Okay. So essentially, it'll come in. The signal comes in over here. If I can draw this. Yeah. No, it's not letting me draw. Yeah.
So the one split capacitor feeds the other three as well?
Yeah, the one at the very end, the one on the bottom of the page, will feed back out into the other three capacitors that connect before each stack 1, 2, and 3. And so these would be separate from the two split capacitors that are already inside of the coil stack. And as you can see on each set of coils, the orientation I've kind of tried to make clear of when it's feeding into the line or when it's feeding out of the line based on where the line comes out of on the coils. And the direction of flow again is from the top left to the right and then back to the bottom of the page.
So it looks like you've got two feeding or two feedback loops from coils 1 and 2.
Mm-hmm.
One from the primary capacitor at the bottom, and one also from the capacitor at the end of coil 2.
Yeah.
You know, I've made one with the split capacitors that he's talking about already, that we've done already, just the two.
Mm-hmm.
And it seems like you're getting a lot of wire, you know, just in one spot on that first one and so forth. But it just, I don't know, this might seem just like a little too much wire to me. I don't know if anybody else agrees.
Like a bit of overkill, you think?
Maybe. I don't know. The one that I set up, I just sent it out today. I can't really show it, unfortunately. I just gave it to a family member. So, but it seemed there was just a lot of wires going, you know, everywhere. It seemed like on it.
Yeah.
But
Well,
it did.
Go ahead.
Sorry, I just said it did end up working. It was powering, you know, a 20-watt light bulb when it left, so it was working.
Good side. Yeah, I thought that by using more feedbacks, it would mimic a magnet or a plasmatic system like the Earth more, where there's a lot more feeding back into itself.
You might want to use finer wire so that you can make it more compact or smaller, miniaturize it.
That's a good idea. We'll try that.
Yeah, that might bring issues with conditioning, because the conditioning load is going to cause that wire to heat up. So you'd have to be very gentle with your conditioning.
Okay, that's a good point. Thank you.
But it looks like there's 3 on the first capacitor. There's 4 on the second and 4 on the third.
It should actually be well, the 3 outputs on the first capacitor, 1 input. On the second one, there's 2 inputs and 2 outputs, 1 going forward, 1 going back. On the third one, there's 3 outputs and 1 input, 1 coming in from the last one, and then the 3 going out forward and reverse. And on the last one, it's only outputs.
Okay.
Okay, I see. I think what I'm seeing here is I think of it a little bit differently. The wire going through the center connects stackers together.
Yeah, that's what
like
I've been avoiding.
Oh, okay. Because I was going to say, look, yours has the last coil goes to the next one rather than actually having
Exactly.
Right? Okay.
Yeah, so I'm trying to follow like the original capacitor design a little bit, because I'm not sure as to how well it would perform if you keep it going as one straight wire, as opposed to if you have like a plasmatic intermediary.
I see.
Very interesting.
The ones that we put on the stacker are after all 3 stacks. And from what I understand, I've used a couple of the different setups with that. But the plasma is not actually, or the electricity does not go through there, I should say. It doesn't connect between the center and the outside coil. It's just to hold certain amount of plasma there, from what I understand. And
Yeah, well, the electricity is not going through the stacker at all because it's connected to a super insulator. So it's whatever's coming out of that unit is plasma.
okay, so because I've had experiences where I wasn't able to draw anything from it until I took the capacitor out of the line.
You may have had a barrier condition with the plasma in your capacitor, where you're trying to push two streams in opposite directions. You understand what I mean?
No, because I had it set up in line. It was the negative on the capacitor was just basically in between the wire, two lengths of wire. So it wasn't connected like between the neutral wire and the phase or anything. It was in line with the phase.
So do you mean in series?
Yes, it was in series with the phase. No, I'm sorry.
And
It was
all
in
of your
line.
coils, the coils on your capacitors, all of your connections were all the same direction?
Yes.
Okay.
I don't have that stacker here, but I can show you what I'm talking about. Maybe it'll make it more clear.
No, I think I understand what you're talking about. I'm just trying to look at where the potential barrier could have been that would have stopped your plasma flow.
Yeah, I've had that experience more than once, actually. And so now I connect them like it shows on the blueprints. That was before I had the blueprints. I don't have a lot of technical stuff here, so I wasn't able to get the blueprints right away. And now I connect them between the phase going in and going out, and then the neutral and the phase.
Right.
And that was just the first thing that I thought, was to put them in line, like the negative on one end and the positive on the other, feeding, so that it feeds through there and it wouldn't flow at all. As soon as I took that out, though, it was just fine.
I see. Oops. Oh, there was a hand up. I'm not sure if there is now.
I can also show that battery, Rick, if it helps.
Sure, go ahead.
Okay, one moment.
Yeah, I'm very curious about the batteries. We've had a lot of questions in the tech support area about standalone systems lately.
Can you see my video, Rick?
Yeah, let me spotlight it and get it up here. Okay.
Okay, just a second. Let me switch my camera. Okay.
Right.
Oh, it's inverted again. Okay. So this is the battery that I made thinking about what we were talking about in the last plasma group. So it's the outside coil, one more coil, and then a center wire. Let me see if I can rest my phone so that oh. Three portions of it. I'm sorry. Hold on 1 second. Also, I just was putting together the battery that Hugh showed just now with the floor. Out. You were saying that the two center ones between the center and the two middle ones, I'm sorry, would be feedback. One would go to the center wire and one would go to the outside wire.
Well, I was thinking of using the inner coil and the outer coil as your feedback coils so that you have a constant flow flowing through the middle coil.
Yeah.
Okay. Tapping off from the middle coil.
So you would use both of them for the middle coil, right?
Right.
All right, cool.
Please, that's what came to mind when I saw the picture anyway.
Yeah, absolutely. No, I agree. It needs to feed back to itself in some way. Okay, so And these have just been nano coated. I haven't had a chance to GANS coat them yet, but they turned a really nice blue color too. Yeah, it's hard to see, huh? But with caustic, I've had a little bit better luck with caustic. When I do my home readings, after fire nano coating, I don't get 100% resistance, so I'm cautious. That's after about 6 or 7 times. I've still got them hanging up. One of them. Okay, so it's still kind of shiny. And if I go any further than what I'm going with the heat, it seems to go almost red hot. I don't know if I've got copper with impurities in it, or if it's something else that I'm doing. But I've just been going back to the caustic because I know it works.
Right.
I've also got one at 90 degrees where I've twisted them at 90 degrees and hooked a plasma battery in between. I hooked just a nano-coated copper wire on the on either side, the gravitational and the magnetical. And I've been just kind of holding on to it whenever I feel like I need an energy boost or balance or something like that. And it's been working quite well. It's just something that you guys can look at or think about, whatever. So I'm unable to get the center wire out of this one, but basically you guys know the setup. You would GANS coat and then a piece of paper, wrap it around that. The aluminum foil would go around the paper and then insert it into this next coil. I'm sorry, I'm having trouble with this camera. It's inverted now.
Not for us. I think it's okay.
Okay. And then I would do the same again on this coil, wrap the paper with dried GANS around it, the aluminum foil, and then insert it into this one. So then the center 2 wires would be the positive of the battery. Let me put it back in. And the center wire would be the negative, just like we're talking about today. One of the gentlemen was talking about wanting a toroidal form with this. And so I figured that you could actually connect one of the two outside, make the toroidal form, and you've still got two negative or center wires, and then 4 really outside or positive with the 2 connected here. I was wondering, would that feed back into the positive? Shall I connect one of the negative with one of the outside positive and use one of them for feedback, or maybe 2 of them since I've got 4?
Well, you're only going to want 2 outputs at the end of the day. So yeah, I would think so. I'm just not sure which one's probably going from the center coil to the outside coil, using one side of the center coil as one leg, then the outside of the outer coil is the other leg.
Right. Yeah, I understand that. Then what I'm thinking is you would use, to make the toroidal figure, you would just use whichever wires you aren't going to use at the end of the day, or negative and positive, in order to feed back to the negative. Put both of them on the negative, maybe. I don't know. I'll try it and let you guys know.
Okay.
What happens. I'm getting a max of about 1.3. What I do is each batch of GANS that I have, I just make a little battery out of it and check the voltage on that. And then when I make another batch of GANS, I just know how they kind of compare to one another, at least in that manner. I don't know if that means anything about the actual plasma, but so I just tape one of those to it. I get a max of about 1.2 with just that. I've never added titanium dioxide or sugar to them though.
Robert?
So I can do this very easily with that. Yes.
This is Denny. Have you gotten to the point or headed toward the point where you've got a system that does
your nano coating with plasma yet?
No, to be honest, I gave them all away. I had great results here with my house, and so I've just given them all to family and new family that we went and bought some wood from for the fireplace before, and we've just been giving them away, trying to stay in the Christmas spirit, I guess.
Well, that's good. I was just wondering, well, at some point, I'd like to get rid of caustic and heating and go directly to plasma nano coating, and so it's one of the goals, and
Yeah.
I thought maybe you had already done it.
No, but I've got 6 systems about to be done here, and so I'll have enough for my starship formation as well. So I'll try it out, and from what I understand, you just hook them together and hook them into the outcoming stacker unit, and so I'll give that a shot and let you guys know how that works out as well.
Well, in theory, the device you showed us earlier with your 2 coils at 90 degrees with the plasma battery on it should provide a plasma output to do your nano coating with. It might be a little slow, but it should work.
Yeah, I was gonna say, because I used heat to nano the 2 of those. That's why I'm using them the way they are now. And whenever I bend the wire, it turns red, and it has not been nano coated. I mean, it still looks nano coated, but I don't know if you can see it. It just has a big different color.
Yeah, it's kind of dark. Oh yeah, I can see that.
And so if that starts to nano coat itself completely, I'll let you guys know. My car systems, I've got one in my truck and one in my wife's car, and I connected them with copper wires, and they are completely nano coated at this point. It's only 3 weeks maybe, and all of the copper that I can see has been nano coated. It doesn't seem like it does anything to the stainless steel that's attached to them, though.
Have you noticed any difference in your car since you put the system on?
Yeah, we would get 360 miles per gallon max out of my wife's car, and we got 412 the last time. Also, the battery was dead basically when we put the system in, and it's very, very cold here. It was -7 Fahrenheit here the other day. I think that's like -15 Celsius, something like that, or no, more than that. But and the battery's still been working. So, but we had to have it on a charger previous to that at all times.
Very nice. Thank you.
And my truck, I just don't drive quite enough. I haven't even gone through a whole tank of gas to check it. Yeah. But everything that I've made so far has worked really well. I've got a lot of negative Nancy's on my YouTube, so I haven't really been posting there as much recently. I mean, I feel like I spend a lot of time just trying to stick up for the technology, but if they go and try it, they would, figure it out themselves. So I don't feel like it's worth saying anything about it.
What you can do is just click the comments thing on your YouTube, so you don't have comments, and that solves that problem. That they can't leave a comment, and then people want to get a hold of you can say something, appreciative of it, rather than deal with those negative comments, because sometimes they could be up for days before you notice and so on, and it's not.
Well, I'm not going to take any of them down. I have great answers for all of them, I think.
Well, there you go. I mean, that's the other way to deal with it, is just answer them honestly, the way you believe, the way the plasma works, and end of problem. If they can't figure out the plasma, well, too bad. It's up to them. Just put it in their lap. Plasma, to me, the plasma proves all, and you can simply and easily explain most things through the plasma process that would take forever to explain any other way. So it's a very elegant way to let people know that there's something different going on here. We're not in Kansas anymore, Dorothy. So.
Oh, someone is back.
Sorry. What's that?
Selma,
Oh,
have you got your? He's trying. He says he's got a photo in Facebook, but I can't find his Facebook right now. So
No, I got it on the plasma RAM.
Stop sharing.
Somebody share that. I'm not that computer savvy.
Plasma Realm, is that the Facebook site? You mean?
Correct.
Okay. Let's see.
Hey, Rick, while you're trying to find that, I just noticed something come across my desk that 4.9 earthquake hit Victoria, Canada.
Aha!
Belt.
And what? Pardon me, Belt?
4.9 earthquake hit Victoria, Canada.
Yeah, that's where I am. And it. What about the belt?
The what?
Did you say something else after that?
No, just a 4.9 earthquake hit Victoria, Canada.
Wow. There you go.
I thought a bird just flew into the side of your house.
Yeah, well, I don't have that sturdy of a place, so it could, but no, it was definitely a shake. So thanks for the confirmation on that. Wasn't just me shaking. Interesting. Very interesting. Okay. So actually, it's actually a perfect confirmation in many ways. Okay, these are kind of interesting looking little coils too. Are you going to put those both together? Okay, from pointy end to pointy end. Yes, I've seen that before, and also you can do what you have there, but enclose the whole thing inside of the reverse cone. The other one, like that one, yeah. So you put one inside the other, and that way the plasma gets both created and contained. One's for containing, one's for creating.
Absolutely. Yeah, I figure it's just like a magnetic field, so it looks like.
I understand as a magnetic field, at least I should say. I didn't get or anything, but I've done a lot of research over the years.
Yeah.
Robert, I put a link in the chat of a YouTube MIT class on spherical coils. If you get a chance, if you ever want to take a look at that, it's fairly long, but it's there. So if you copy your chat, you can get it.
You said it was on your YouTube?
No, it's not my YouTube. I put a link in our chat here at the Zoom chat. It's an MIT. I don't know what I even said anymore.
The chat.
It's
oh, there it
link.
was. Right. You mean, okay, there it is. I just showed up here.
Can't even find it myself.
Is that
the? It is. It's an MIT online class.
Right, right.
It's a YouTube link, and it's field and coil and inductance of a spherical coil. And so the spherical coil is what I was trying to show earlier, but I was also going to put a coiling around the actual wires. So enough said there. I was just letting him know that I had put a link like that if he wanted to study about some of the qualities of spherical coil.
Yeah, thank you. I actually saved it in my playlist. So
let me show you. Let me show you one of my coils here.
All right, Rick. Yeah.
I've shown this before several times, but I'll show it again. This is something I made up, and it's got very fine wire inside here, so it's got like a double cone inside, and then of course the other heavier 10 gauge or something on the outside. This actually plugs into a little radio unit that I was working with. But this design, the double cone-shaped coil, was named the football coil. And Tesla actually worked with this shape of coil with the wires wrapped around. I think it was all one continuous wire. And he said this shape of coil had particular anti-gravity qualities to it. That's the rumors that were held. And there's actually people that have examples of this coil. One of his helpers has one of these. I think they rewired it and tried it out with different frequencies and so on, but they weren't sure what to do with it. And still, the jury's out on that. I would like to nano coat this actually and play with it a bit, but I think it's a really good idea. I mean, if you look at what could be inside of this, like what if you had a nice vacuum inside of this and all nano coated. I mean, if I was a plasma inside of this, I'd be pretty happy bouncing around in there because you wouldn't be hitting anything. All you encounter would be a magnetic field here, and you'd bounce back this way. Oh, another magnetic field, and it would just be back and forth with no loss of energy. You'd be happy circulating around in there and without bouncing up against the dreaded walls of the reactor, which is the plasma's nightmare. You know, it's like hits the wall, game over, no more plasma. So I think this has a clue. The shape at least has a clue, and also if the what do they call those things on the Otis Carr flying craft? The Utron units. They're on the outsides of the saucer are also this shape. And I think they had them at an angle, something like this, and they rotated. And they weren't wires, I don't think. I think it was just...
no, they were solid aluminum.
Aluminum, yeah. So, interesting. Maybe we need to explore more that particular shape. And
well, I found Solomon's pictures.
Okay.
I got him here. We can go through them. Have a look. Looks like it was just a cell phone camera, so they're not really clear. But this is the first one, and I would assume this is his stacker unit sitting on the box.
Mm-hmm.
Next one over shows what looks like a stacker unit sitting inside a star reactor. I don't know what this box is in front. Maybe that's his capacitors. Is he still with us? I don't see him on the list.
Yeah, wouldn't you know? Okay.
Just in time to get his stuff up here, and he can't describe it. And also, I got this zoomed in. The pictures are pretty small, so they're a little grainy. Yeah. And over here, it's just a fan and a meter. Looks like the edge of the reactor. Maybe that's probably one of his loads. And then another meter, and to pick the numbers, I don't think you can read the numbers. No, it's too low res to read the numbers.
Mm-hmm.
But there it is. I don't think that's very crude. I think that's gorgeous, actually.
Yep, it doesn't look any more crude than most of the home units that we see. I'm going to try to put together a sort of a slideshow of all the various pictures of units that we've seen the last couple of months. And have
there he is.
For tomorrow.
It's rather embarrassing.
Oh, don't be embarrassed. It's gorgeous. Are you kidding? It's beautiful.
The only thing we need is better quality or better resolution pictures so we can see it more clearly.
Stacker unit with the star formation not moving.
This box in front, is that containing your capacitors?
And the coils are all by hand.
Nothing wrong with that. Beautiful. And the wonderfulness about it is it doesn't have to be perfect and it still works. That's what's amazing about this. Can I ask what this is over here?
This is the single reactor that I use for load before the stacker.
Ah, okay.
And the fan or before the stacker for the load.
Okay. Very nice. Very nice.
No, crude, very crude.
Oh, it's beautiful. Don't sell yourself short. This is gorgeous. I've seen a lot worse. Believe me.
In fact, I probably will make one.
I just like to say, the Magra, that I mean the power unit that is here, it only goes up 5 and goes up low, go down 5. That's all. But what I'm paying now, rather than pay say $8, I'm now paying about $1.60 a day.
That's excellent. Very, very good.
Do it. If I can do it, everybody can do it. And just to prove that what Mr. Keshe promised is all true.
Yeah, keep in mind that this is just a building block. This the primary purpose of these devices isn't for electricity. Primary purpose is for a massive amount of plasma output. And because you're getting such a good reduction in your electricity bill, you have a massive amount of usable plasma there.
That's right. That is the point. And that's what everybody needs to be reminded of, that starts trying to crank the numbers and how come I'm not getting 37%, I'm only getting 33%, and whatever. It's not made to be a numbers generating machine and to generate you tons of cash and back on your power bill and that kind of thing.
Get what you need.
Yes, that's more like what it's for, and also you get what you want in a way. You have to set your intention on what you want out of this and what you expect. And if you expect to get plasma and that's something you need and want, then surely that will be what is produced and what gets noticed and what gets used out of it. But if you ignore plasma and only go for the materiality, the physicality of the numbers game, and you might be so enmeshed in that you might ignore or just not be able to see, sense, taste, or whatever the plasma itself, which is right in front of your face literally at the time. So what to one person is one man's plasma is another man's what could we say, poison in a way.
Well, one of the examples I use when I'm teaching the folks on the Skype chats and through the emails is, they're all wound up around, well, this device is electricity. How much am I going to save? What how much load can I put on it? And I try to get them to understand that using this device for electricity is kind of like growing potatoes in the bed of your truck. It'll work, but there's way better uses for your truck. I mean, it's a byproduct. The electricity output of this thing is a byproduct. That's the simplest way I can put it.
That's a good way to put it, I think. Yep. And there's lots of things you can do with a truck bed. I've seen people make it into a swimming pool in the back of your truck. You can do it, yes sirree. But there's lots of better uses for trucks than making them into a swimming pool. Well, it depends. If it's a hot day, it might be the best use for it. But the point is that if you have a plasmatic device, why try to convert it all back into something that's not plasma, so that we can actually use it for some good? This is man's way of doing things, that we want to, as soon as we got something really great, we want to immediately convert it into something we recognize and can deal with and can get money out of, or can save, or something. Or it's always trying to get an advantage out of something. But in this case, it's more like we give to it. We invest our time, energy, and attention into these systems, and they pay us back in a different way. They pay us back through we might increase our ability to feel and sense the space more than we did before, and that might lead us to be able to feel others more than we did before, and maybe even at a distance compared to only when you're face to face before, or whatever. There's different subtle things that go on with humans when they start interacting with these devices, I believe. It's like Alexei says here, every plasma device is a beautiful being. They all have a bit of life in them from their makers. And I think that's exactly right. Go ahead.
Well, like Ali described, when he first got his spaceship device going, he made the mistake of leaving it in his room and going to sleep, and he slipped into a completely different reality. And to him, it was absolutely real. It was just as real as when he's walking around talking to us. So there's benefit beyond anything we can imagine right now.
Yes, that's right. He talks about creating a different world within this, within the environment of this device, and you can enter into that world. In fact, it even he talked about it drawing him in. So there's this attractive sort of force in these units, which can interact with us. And this is what we need to learn more about, and that's why we start off at the lower energy levels and not dive into the extremes right off the bat. Sorry, go ahead. Is that Salma? Okay, he's accidentally came in, I think.
I might need your help, Rick.
Okay, Danny?
I'll have one thing that I need is I'm having difficulty finding LED lights that I can get my hands on quickly. What have you found so that you can make your
what I did? Well, there's two sources I know of for LED lights. The one in Canada that I go to, and I don't think they have them in the US, but it's called Princess Auto, and it's kind of an all-purpose. They have all kinds of electrical and mechanical stuff, and they happen to have a nice little box of LEDs. Let me show you, just show you what it looks like.
Yeah, I think we're talking about LEDs, the electronic component, not the LED light bulb that you would screw.
That's what I mean. Yeah. So
the Source, Radio Shack, well, any electronic component supply will have them.
I just got this a couple of weeks ago, LED component pack. This was like $14 or something like that.
Old Radio Shack stuff.
And it's got different sized and colored LEDs in there. And the ones of particular interest, in fact, I pulled one out today, is this little guy, which is kind of handy. It's got a nice little screw thing on the top, so you can put it in a panel if you want, or some sort of mount. And two nice leads that are on there really heavy duty, good size wire, already pre-tinned, ready to go for soldering and or connecting or whatever. And
especially for the CO2 kits is what I'm trying to
right
get at. When I'm teaching somebody how to make a CO2 kit and I don't have an LED light, then I'm lame.
Right. So the other source is literally the source, commonly known as Radio Shack, or used to be known as Radio Shack here, and then they turned into the source. And that's another place you can get LEDs. So far, they're scrapping just about everything they have in terms of electronics. People aren't doing that kind of thing anymore. They just buy their
Where
iPad
are you
and
at,
that's it.
Denny?
Yeah.
Iowa?
Idaho.
Denny, this is Robert in Utah. The dollar stores here have these wands that have about 8 or 9 LEDs in them. And so I've just been buying those and then going in and cutting them out. And it's only $1 for, 8 or 9 of them.
Yeah, that'll
Not a bad idea. Mm-hmm.
That's a good deal. Thanks.
No,
Yeah,
by
no
the way, in electricity shops now you find LED lights in line for the Christmas tree, in all kind, and also such a high power LED lights like this one.
Right. Yeah.
It's for 230 volts. It's a 20 watts power. It gives more light, like 100 watts halogen.
Mm. And how
This
much
is good for conditioning the MAGRAV units.
How much do they go for? How much do you buy that for? Where you are?
About less than $20.
Mm-hmm. Yeah, they
it was
have
special price. Otherwise, it's about $50. Some normal price.
Yeah, they are quite expensive. They have lights on a stand now, like trouble lights on a stand like those now, but they're quite expensive still. About $50 each. Nice.
By the way, in the house just now, I replaced several main lights with LED lights of 15, 18 watts, and gives a beautiful light. So now we have LED lights which have a pretty nice color, warmer color, not that very cool, which was in the past. And it's good also for saving.
There's an app called Wish where I'm getting those.
Sorry?
So you guys know.
Go ahead.
There's an app or a website called Wish, WISH, where I'm getting those LED lights pretty cheap.
Okay. And what were you going to say, Danny?
Well, I've got to write that down. WISH, Wish.
Yeah, I think that's what it was.
Denny, if you're in Idaho, I'm in northern Utah. If there's any way you could send me a email address or something, maybe we can hook up and do some work.
Yeah, my email is not sacred. It's dennystark8@yahoo.com.
Okay, great. I'll get in touch with you. Thank you.
Now, Rick, I'm going to change the subject because I had such difficulty this morning explaining a spherical coil. Go to Google for me and write in spherical coil and then click on images. Would you do that, please?
Denny, I sent you a link in the chat, an eBay listing for LEDs, 100 of them, cheap like dirt.
Thank you very much. Thank you very much.
Oh, look at all the spherical coils. Mm-hmm.
The one that I'm talking about is that one that's by the jewelry one, Cone Design.
Hello, Rick.
Amy Cone.
I'm not. Oh, the inductive coupling field symmetries.
No,
that's
it's
cool
like
one.
a bead. It's like a jewelry bead.
Hello, Rick.
Hi.
Salam again. Can I continue with part 2 of my testimony?
Nope, we're dealing with Denny here right now.
Well, no, you guys, Just hold on a second. We'll be right with you.
Yeah, thank you.
Yeah, but you can if we can in a minute here. Yep.
Well,
I'm not sure which one you mean. I don't want to put all these on the screen because
don't. I'm just saying
I'm
the
going to
one
go
that
back
looks
to
like
here though.
what I was explaining is the jewelry bead.
Jewelry bead. Okay. I'm just trying to find jewelry bead.
It says jewelry. I think it said 407 times 381. Amy Cohn Designs.
Okay. Yeah. Okay. I see that.
Would you click on that?
Mm-hmm.
Now that's what I was trying to explain.
Right.
You got your center wire, and then you put your coil around it.
Yeah. Cool. Mm-hmm.
And that's and if you had two of them, but then when you go up there to the other, there's a coil there that's the MIT one, but that's it. That's all I wanted to do is give you a link like that. Now, if you can show that, that would be great. But it's not necessary.
Well, I can show the whole. I can show the whole website, and that's okay to show. So I'm going to show this jewelrylessons.com tutorial website.
I don't know if you'll find it right then on it, but it's okay.
Yeah, I searched it through the other thing there. Let me just share the screen. Safari. So, and now we have this coil wire spherical bead, it's called. And this will actually be quite small. This is a tiny little bead, not a.
Well, no, but I'm just saying that's the prototype.
Yeah.
You can make it the size you want to. You could use any material you wanted to. I've got a bunch of nickel wire that I bought that people use in their vape systems.
Mm-hmm.
And I bought some titanium wire that way. It was cheap. I couldn't find LED lights, but I could sure find that other kind of wire.
This is interesting that there's an actual instructions or how to make it. It costs $4.50 to get the instructions from Amy.
You make
on
it just
how they
like
made
you
it.
do the spiral.
Well, she said something about, well, she went through meters of wire and finally figured out how to make the bead she wanted, and something about it couldn't find a way to make a perfectly spherical coiled bead, so she found out a way to make it, apparently. Sorry, go ahead.
I actually made like that, just big one.
Mm-hmm.
It looks exactly like that, but it's looks like coconut.
Uh-huh.
Long time ago, but
it looks like a very secure structure. It looks like if I were a plasma buzzing around inside that, I would probably be pretty happy too. It's like, again, you would have, I would think a more or less continuous wall system that you would be bumping into, so you wouldn't bump into the walls. The nanomaterial or the fields would keep you away from the walls, which is the main rule number 1 or 2, one or the other.
But you can do this at the same design that you were doing of the football coil.
Yeah.
You could make it into that football shape.
Yeah.
And put the coils around the independent wires. Of course, the one that you've made, you're using real fine and you're doing multi-wrap on it.
Yeah, that was a different thing. What was more for high voltage, and it was insulated wire actually, rather than bare wire. So it's a different situation, made for resonant frequencies and so on. Nice. Okay.
Well, that's enough for me. I saw those LEDs. They come out of China. It takes a while to get some out of China.
Yeah, you could get some local ones. They'll be a little more expensive and so on. But
Yeah, just look in your yellow pages or dig on the net for electronic component supply. and they'll have them.
Well, I guess I've been too lazy, huh? So I'll work harder.
Yeah.
Thanks.
Can you see, guys, my video?
No.
I can see Sandor.
Okay, Sander have to
Oh,
somehow.
there's Modris. Okay, here we go.
Yeah. So this is the ball that I told you.
Oh,
I made it a
nice.
ball.
Yeah, that's very much like what we just saw. Cool.
Yeah, just like about three months ago or a bit more, 4 maybe. And this is the coil which I told like how we could make, and I just while we were speaking, I made it. So basically, you can nano coat and use with all cover. Because I remember Mr. Keshe was explaining how good it is to use with the cover, and somehow we went aside of it, and maybe we should talk about that more, and maybe it's also could be useful.
Yeah, I think so. If like
that's
Okay.
beautiful, but how will you put the guns on the top of the nano coating if it's under the PVC?
So GANs you will put on plastic, and then they will create the different type of GANs between the plastic and the copper.
Like, do you need the GANs too? Would be another question, because if you
It's
look at
the
the
storage.
surface between the nano copper and when it changes inside the insulation as it gradually goes around and turns black, it's going to have essentially a vacuum condition next to where it connects with the plastic insulation. So that interface could be very special because the plastic's going to start getting nano-coated, the copper gets nano-coated, and the interface between the copper oxide and the carbon coming out from the insulation could be very interesting. What are you trying to show, sorry?
This is the another one which I showed with that wire which you not make. You see, usually here it goes straight, and I made it twisted.
Mm-hmm.
So
Interesting.
And physical how it looks. It's become thicker.
I suppose in theory you could whip that all the way around and then stick the plain wire back in through it again.
Yeah, I thought about that actually, but it's like then you have
the snake eats its tail, eats another snake's tail, or something like that.
Yeah, exactly.
This is Denny again, Modris. I'm looking at your spherical coil. What was your intent with that?
Because I thought because you see there is the another one inside.
Yes, I do. I see it.
And there is actually another one which goes like a twisted. I was trying to create the like tornado, or you see there is another one inside. So to try to to make this twirled fields, one goes straight, and then there's another one goes, and then the gravitational inner, and then the magnetical outer. Now I know I was connecting wrong. It was actually working, but then it's first this is wrong, and there was I was trying to make the capacitor with the metal shavings inside and against, which was like being said long time. I was working a bit, but it was start heating up, and you can see even like here is like good. So, but there was a wrong connection. Now I'm like very clear now. So one day I want to connect it again.
Can you use that as a single stacker system? Is that what you're trying to do?
That is one core.
Nice. I can't believe that we were trying to come up with a picture on the internet, and here's Modris just happened to have it in his hand the whole time. Classic. In fact, he's taken it several steps further.
Yeah, if I would share, most probably we'd all come with some point how to connect it correctly, and maybe it would not waste the time on my shell.
I wonder if knowing more about the way the inductive magnetic fields work, is that information that we should be playing around with, or is it important or not? What do people think about that? I'm talking about, there's programs that if we were to put an input of certain voltage into that and so on, should just put the criterion, it would show the magnetic fields of the induction caused by the coils of wire and all that kind of thing.
That's what that link was from the MIT class.
Right.
And I haven't completely finished that, so I'm still in the dark. But it has just the fact of the spherical coil without the coils wrapped around it, like Modrus has, but just single ones. It has some just built-in inductance that has an amazing quality to it.
Mm-hmm.
Like you were talking about the football coil. So we're not dealing in the vibrations, but we're dealing in the plasma. But a lot of this stuff, they didn't know they were dealing in plasma when they do research on things like this. They haven't been looking in that direction. They've been looking in another direction.
Exactly.
Yeah, I was recently researching some studies with magnetic bowls, where it seemed like they were kind of viewing plasma, but didn't realize it, or kind of in the same field.
Could you show us that again, Doug? Oops. Nice. That's two shells, right? Two shells together? It's not one, yeah.
That looks like orgonite.
But boy, that's an idea. I mean, how easy would it be to hook those two shells together? And it's essentially a type of nanomaterial, maybe just putting it in caustic and sticking it together is enough to create, it seems like exactly the right angle somehow, doesn't it? It's pretty darn close to what it should be somehow. Of course, nature. Look at that spiral on there. Is that
They're two shells.
I wonder what kind of spiral that is. That's what we call the right hand.
Anti-clockwise or clockwise?
It's a right hand spiral. Look at that. Boy, amazing, eh? Look at that. Beautiful. Beautiful example. Thank you, Doug. You just happen to have
lying
them
around in my house.
Just happen to have them handy for the demonstration. Thanks.
No problem.
I love it.
I do too. Beautiful.
All right. Anybody else have any practical examples of? Selma, you got something else you want to say? There, your hands up.
Yes, Rick. But be patient because I'm having a charging problem with my phone.
Okay.
I'm talking about another reduction.
Another reduction. You mean from 80 to more than 80? Is that you're beyond 100 now and trying?
No. I'm 60 plus years old.
Oh, okay. Mm-hmm.
But I feel my body is 40 years old body, in a 40-year-old body because of the plasma. My reactor and all that is in my bedroom, so I'm getting rejuvenate and I'm getting restoration and strengthen my body.
I agree.
You understand?
Yes, I totally agree. I'm over 60 myself right now, and I actually feel more like 20. And the last time I went to a doctor, he said I had the heart of a 20-year-old. I told him, well, geez, 20-year-olds today, I'm not so sure if I want to have a heart like them because most of them are in pretty bad shape. So I'm glad to have the one I have.
Worked you over too.
Pardon me?
Francois worked you over too.
Oh, I'll say I felt sick for days after that, but I survived. Yeah, sometimes you can have a elimination reaction from examples like that, and I think that's probably what happened. But yeah, that's all that kind of thing. It all helps to place the focus and place the attention on things that we normally have overlook. And all of a sudden, our attention, I think, can perform miracles when we put it in the right place and get everything working the way it was meant to be, essentially, in our bodies and in our essence. I figure I spent the first half of my life getting myself messed up, and the second half of my life trying to figure out how to unmess myself. So it's part of the way of humans, I think. One of the best ways to learn mechanics is to buy an old car, fix it up. Okay, what else we got to share here?
I got a question if no one else has anything to say right now.
Go ahead. Mm-hmm.
Just wanted to know from other people's experiences when they hook up a circuit breaker in the input for their hot coming in from their grid, do they notice the nano coating going through that?
I asked Mr. Keshe that question, and he seemed to say that it didn't matter in terms of the plasma going through and doing the nano coating thing, but we've had other responses in the other way too. It might depend somewhat on the materials that are used in the circuit breaker. I mean, some circuit breakers are actual fuses. You have a large fuse, and they have often stainless steel caps, and it could have a lead actual fuse part inside. Other ones are just a circuit breaker where it actually disconnects from the contacts inside, which are often just copper contacts, which if they nano coat, well, I don't know how that affects it, because I mean, it's a strange thing, because when you think about it, the nano coating, I'll give you an example here. I wanted to show anyway, so throw this on, and like this is an example of a quartz crystal that was given to me several years ago, actually, to experiment with, and it had the coils on it already. This is regular copper wire, and I nano coated, left it in a small plastic container with some caustic, and it nano coated over a couple of months. A nice, beautiful, shiny nano coating. I'd forgotten about it, and I went in to look at it, and said, whoa, that's nice. So I put the meter on it to test it, and sure enough, there's I can't get any resistance reading on it. It's got so much insulation, so much resistance that it doesn't read on the meter. It's at any points on the coil, you get no reading. If you put on voltage, you get a low voltage reading off of it, but there's basically infinite resistance. I'd have to use a meg ohm meter and do a megger, they call it, and do a resistance insulation breakdown test and see just how much insulation there is in these in this coating. But it's amazing. It actually insulates electrically, as John has mentioned several times, and others, and of course Mr. Keshe and so on. So if that's the case, then when these wires are hooked up, in the units, you would think that it shouldn't be making actual physical contact with the system as such. So in that sense, what happens at a circuit breaker if it's actually nano-coated? And if you were to disconnect and connect that circuit breaker, if the contacts were nano-coated in the way that this is, then theoretically the power wouldn't be coming through that circuit breaker and it wouldn't be feeding into your house and its lines and so on, at least in the normal way that we think of electrons moving through copper wire. Generally, if we see wire that's black, if you were an electrician and saw black wires inside the walls of a house, you would go, oh, got to replace these wires because they are burnt. Because if copper wires get overloaded in the household circuit because someone's put in a bigger fuse or stuck a penny under the fuse or something like that, then the wires can overheat. They get pretty much red hot, and when they cool, they form that nano coating on them. If they do that on, say, an extension cord, then you pretty much have to throw away the extension cord because it won't be able to handle the power. It'll start to overheat, and then eventually it could fry itself and melt and that kind of thing. So that's the way it is with the ordinary, in the ordinary sense. So what happens in the house when it gets nano-coated? First of all, it won't be in this extreme of nano coating. It'll be in micro layers rather than, not micro layers, but in a low number of layers rather than, thousands or tens of thousands, which would be the case of something like this. And so even though it may be insulating, as soon as those contacts come together, they're probably going to break through that connection and cause a matter-to-matter contact in the circuit breaker. So I don't think, but on the other hand, the nano coating is going to go over those contacts and carry on through the next wire, because it's a plasmatic effect that's going on rather than a matter level, and it's at basically an atomic level. We're talking about maybe even a dozen or less atomic layers would be enough to cause hugely different effects on the skin of that wire or of that circuit breaker. And because most of the current carrying is usually around the skin of the wire, not inside the wire, then it would make a huge difference in the way that the plasma moves on it as well. It'll be much more conducive to moving plasma along the whole system, the way I look at it. So I think that it's not going to hurt the circuit breakers. On the other hand, I don't think the circuit breaker is going to interfere with the plasma development along the system as well.
Right. So like the entire house from just one line, say like a circuit panel has maybe 20 circuit breakers on it through different lines. Just by conditioning one line or focusing on one line, the plasmatic effect should reach the entirety of the house wiring, regardless, right? Because it's all.
Well, I would think so eventually, because you're doing a plasma coating process. But on the other hand, the plasma will be trying to feed back through the system along one particular line or one particular pathway, I would think, too. And for it to feed back on all the other systems in the box, it might be slower doing that than working directly through those wires. Like if you had a system on each one of the legs of that electrical system, or put the unit, start at one part of the house and keep working toward the box from different parts of the house or something like that. it's sort of debatable whether one way is more effective than the other. To me, I would just set up the unit in a place that I wanted to have the unit, and then have it essentially broadcast from there, have it get acclimatized and conditioned to its space. And then I think if the reactor's happy and I'm happy with it and everybody's happy, it's going to grow from there. It's going to want to spread out always from that central location, like an octopus kind of just spreading its legs out. So I don't think it's as important to sort of to me, the flow is going to go from a central point out. So in other words, it'll go in all directions rather than along the lines and sort of back that way, although the lines seem to direct the plasma at the same time if they're nano-coated. So it's a little bit debatable in terms of that theoretical end of things. I guess we would have to be there and see it and test it to know particular situations.
Thank you so much.
Rick, I would like to show you something.
Alrighty. Mm-hmm. Please do.
Okay. Second. Yesterday. Can you see? I was trying to switch the camera.
Not yet.
Yeah. Okay. So let me turn maybe like that. So yesterday I was working on trying to make the new set of the new type of coils.
Mm-hmm. Right.
What do you think? How correct this one is? Like the
Try to keep your camera still, and then the image will clarify itself nicely.
Yeah.
That's good. Yeah.
Maybe I will turn like that because I think it'll be better.
Yeah.
Not really.
Seems to be off.
Oops.
Okay, I see you've got yeah, I think one wire got pulled there when you tried to move it.
Yeah, exactly. Yeah. Thank you.
Oh, the slot in the middle, that's
I
very...
made it, you see, the
you
small
got a
ones.
little one in there. It's made babies already. Holy cow. What are these things doing at night? Look at that. That's very interesting.
Because you can make small ones as well. Why we need to do very big ones?
Well, maybe you could hang that off the top part of the other middle coil there, I wonder, and then allow it to go into the slot a little bit.
It fits nicely inside, you know. But yeah, but main thing was this whole set. This is how it should look, the new type of set.
It looks very nice.
Looks very nice. It looks correct to me in terms of the latest instructions we have. And other than the coil itself, like I like the slot idea. It makes it so simple way to hold the whole thing. I wonder if the touching of the coil, the horizontal coil against the plastic plate, is that an issue, or maybe it's a good thing? I'm not clear on that yet. It's
you mean here when it's touching?
Yeah.
But it will touch something anyway. We can hang it basically, but it's still, if you hang it, you still have to attach somehow.
Mm-hmm.
I actually thought maybe to make it more steady, to like stick them here together. You can see it like that, like, you know, to make them, you know, if you move or something, or they want to move themselves, so they have limited movement.
Right.
Or you make just like a wall here like that to keep it them like that strongly together.
Mr. Keshe mentioned with Ali's system that it's important to keep them the coils lined up properly, like the vertical ones. They shouldn't be like all tilted in different angles and so on. To try to make them all consistent and together that way.
Yeah, that would be pretty secure.
the center
Beauty.
coil is actually touching less surface area than the other one, or than it would be normally with that setup too. So it's not touching the matter nearly as much.
Mm-hmm.
Also, it seems like they're very far apart, and it's going far apart, it seems, but it's not within the 5 centimeter under the bottom of the next coil. It doesn't look like what was on the blueprints. It said distance.
But we cannot do this anymore because and otherwise we will make like, you know, different shape.
Right, yeah, or you'd have to move it out of line or something like that, right?
Or you'd have to make the inner coil smaller, perhaps.
Right, right.
Yeah.
If you're wanting, like, somebody else, go ahead.
No, sorry, you go ahead. You go ahead.
Okay, just for a second. Where since you've already know how to make grooves in the plastic, where your horizontal coil is, you can make several grooves in that as well, so that it doesn't have to lay entirely on the plastic. Did you understand what I said?
Yes, true. Mm-hmm. Mm-hmm.
Okay, I'm done.
I missed it because I was reading what Kevin, and I missed both.
He was just saying you can make multiple grooves in the plate in order to suspend the coil so it doesn't have as much surface area if you wanted to.
Yeah, actually.
Horizontal coil.
And you know what I thought? It's actually very good if we cut out this part, and we can, you know, it would be easier also to connect those ones. It's like they can connect inner.
Yeah.
If you make the another groove here, like, you know, going down.
Now I wonder about the metal rods, of course. If there's a field around the unit, those might tend to interfere somewhat, but it's sort of a minor detail.
I'm thinking about use another one set with by using square, and then it's like more open, like that. So this part will go hang, so like that you can easily connect. So I thought like I want to make it a bit open to also to see more, you know, less interference with.
Is that glass or plexiglass? It on.
This is what they call I call it plastic glass. There's a special name for it. I forgot.
Let's give my
Good
microphone. Is it
question.
polycarbonate or acrylic?
This one actually, it's old refrigerator walls. You know what they use in a refrigerator to separate. So I found them, and there was, you know.
Oh, yeah, they're probably polycarbonate to take the stress. Yeah.
Yeah, they are very strong. Okay, yeah, basically that's it. Thanks.
I was wondering,
Thanks,
Rick,
Modris.
if anybody else is having the same problem. I'm sorry.
No, go ahead.
I was wondering if anybody else is having the same problem with getting an ohm reading after fire nano coating a bunch of times.
Yeah, I don't get a really strong infinity resistance response like I get with caustic coating, but I still do get in the mega ohms at the very least. So it seems that it's still a good coating.
Yeah, I do as well. I was
Have
looking for the same thing with caustic, you know.
Have you guys seen the difference between caustic and fire in terms of the actual nano coating? It's in I believe it's in the golden age of GANs. Maybe we can bring that up. It'd be good to see.
The only thing about fire coating I noticed is that it looks like for a really strong coating, you need to do it several times. Like you have to do it like 6 times over and let it cool down between each take.
Well, that could be too.
Yeah, I've done mine 6 right now, and they still look shiny like I showed earlier. But when I do it with caustic, it's just flat black, beautiful, like velvety, almost.
What about
I can show the difference there, but I'd really like to see this golden age of GANs thing that Rick has to show us.
Yeah, let's check it out.
Yeah, let me get this. See if I can find it here.
Modris, this is Denny. I was going to give you another tip. Instead of trying to put groove for that horizontal one, just put about 3 little risers to keep it off of the plastic if that was what was bothering you. And if it doesn't bother you, don't worry about it.
Yeah, thank you. Then I actually thought about that as well. Just what is the difference? What we know it's most important is to be still, so it doesn't move.
Yeah, I think the fields would go through the matter state anyway. So it doesn't really matter if it's touching the plastic or whatever. The fields will just go through the matter state.
Yeah, because even the units which the power units, everything is touching each other. Like, you know, I mean, the wires lying down on the plastic, you know, surface.
Yeah, I don't think there's anything to worry about.
Basically, if we want to make better, we should most probably nano coat those plastics. That would be like less interference if we worry about that, I think.
Well, I'm trying to find the pictures. I don't see them in the golden age of GANs. It was nano pictures, I think through SEM technique for, and showed the actual crystalline structure of the nano coating of the fire method versus the caustic method.
Can you describe it to us, Rick?
Yeah.
At the very least.
Yep. Geez, there's a lot of pictures in this golden age of GANs. I thought I missed it here somewhere. Maybe it's back a little further. Just a second here. Well, I'm still not finding it. Okay, I'll just describe it. Basically, the way it looks is that the fire coating method leaves like a finer grain, but not nicely formed particles. In other words, the caustic method, you could see some nicely made pyramids and other flat-sided structures like that would reflect light in a special way. And the pyramids are often one of the structures that the copper oxide takes. And if it's done right with the caustic, you can get different sizes of pyramids on this that grow out of the structure, out of the surface. So certain sized pyramids are better for things and other ones, depending what you're doing with your material. And so with electrical things, for example, I think the caustic method is better because you have all these little pyramids which form these plasmons, which are little rotating magnetic fields at the tip of each pyramid. So then you have like a plasma that flows over the top of the nanomaterials. Without the pyramids, then you have a different qualities to the surface, and with the fire coating, it's a different way of doing it. I don't know if it's better or not. I think the other method might be better, but it depends. It's whatever works, essentially.
I found them, Rick. I put them in the chat.
Oh, okay.
What about?
Great. Thank you, Jamie. I'm gonna show these in the.
And then do a caustic afterwards.
Yeah, I think that's a good idea. Quite possibly.
Steaming example.
What was that you said was a good idea? Doing the fire and then the caustic?
Yeah, quite possibly. Quite possibly.
Why to steam after it? Not to put in a caustic, but just steam a bit.
Yeah, that's
Yeah,
better.
That's
definitely.
That's what I'm doing right now. So I can show you guys after. I might be able to go grab one right now and see. You guys can see after fire and then caustic. But Rick, if you could show those pictures, I'd really like.
Yeah, yeah. Here we go. So this is in the Keshe technology processes and results. Just a minute here while I fix this. Technology and processes and results Facebook site, and it mentions here in this little write-up the first 3 pictures are from the caustic method, the second 3 are with the fire coating method. My analysis: the caustic method images are polydisperse and the fire coating have more homogeneous structure. For me, that shows that fire coating is a better way for coating the copper. The structure of the particles have different shapes and no signs of graphene. So let's have a look at the pictures here. Got this one, which is one of the...
At the bottom, you can see the magnification, 10 micrometers. It's one portion like a white or a black down.
Yes, exactly. And let's go to the next one. Now see the difference here. This is, well, of course, this is more blown up as well, but see 10 micrometers is that long bar at the bottom. But what?
This is a crystalline structure produced by the caustic method.
Right, exactly. So isn't that beautiful? And, you know, you can imagine with a more, even more scientific methods, or at least, you know, methods that are controlled, how we could get a very, very consistent size of, essentially these are pyramidic structures. Some of them look more like squares, but most of them are like a truncated pyramid. Okay.
That helps to make the pop that Mr. Keshe talks about make sense, to where it kind of pops off like popcorn.
Yeah, in a way.
This is the same at the higher magnification. It's 1 micrometer, 1 centimeter there on the picture.
Yeah.
And what are those flaky things between the crystals?
Yeah, really. What is that?
Style formations.
Pardon me?
So in the first comment was no sign of graphene, but what's that flaky structure between the crystals?
Well, I don't know. It's strange.
Caustic or heat, because it could be leftover caustic.
Could be, yeah. Or maybe sodium or something, but
right.
Boy, it's almost like a... See how the tendrils, like in here, seem to be attached to these crystals. Like this one goes right into there, and this one attached. They're like a nervous system or something in the brain, maybe. These things that nerves. Yeah, fungus.
What I'd like to add here, I'd like to add here something. We had no information how this nano coating was produced. So was it polarized with a small voltage or not?
Mm-hmm. Right. So this is, I think we need more photographs like this, and really itemize what the process is that we do. And this is one of the fire methods, right, Shandor?
Yes, it's made by fire, so you see a finer structure. It's a much finer.
Yeah, no sharp edges at all. It's all rounded, more like little globes, you might say, little blobs that sort of got melted maybe, or at least they're not growing as the same kind of crystal structure at all. Not to say that it's not useful, or it could be better for certain things. You see the holes and so on inside here that could be useful for transporting charge, because that's the way charge can get transported, through holes, through vacancies, rather than the actual electrons.
To me, it'd be also interesting to see a nano coating by plasma.
Mm-hmm. Mhm.
Yeah,
So I get-
right. Sandro's right, though. If this were polarized and directionalized, I almost expected it to be in line. But like you said,
Don't forget this magnification. It doesn't allow to see anything at the atom level.
That's right.
So
We're still
one
looking.
micrometer, it's 1,000 nanometers.
Yes.
And atomic dimensions are measured rather than with nanometers with angstroms.
Yeah.
Anyway, it's very nice to see these pictures made by this Bulgarian scientist, Veselin Velichkov.
I'm totally intrigued by the idea of creating pyramids, an actual pyramidic structure that's very regular, and the pyramids are anchored in, and it turns out that let me come up with a little piece of information for us here, if I can find it again.
Yeah, in this picture, you can actually see a bit of a structure in there. You can see a flow to the crystalline structure. This could be related to the extrusion of the copper. It could be a texture on the copper itself.
So before to go to such expensive tests, it would be good to make a set of nano-coated materials using different procedures with giving polarity or direction or without, with having less layers, like a more transparent diamond style coating and a blacker, darker one, and to make a comparison about how to learn how the different methods will change the quality of the structure.
Yeah, or we can look it up, because a lot of this has already been done by scientists, and they have a very, very exact ways of creating. This is one thing here. Here's the synthesis of size-controlled and shaped copper nanoparticles, for example. Came out in 2007 from the New York University or
These
whatever.
are particles, not layers. That's the difference.
That's right. Yeah. But
by the way, has anybody
the idea is same with the particles as for the layers. Basically, you manipulate the temperatures, the pH, and a couple of other factors, and basically you can produce different ones. There's triangles or pyramids in here. There's rods, and there's cubes, are all within this structure here, and you can see at 200 nanometers, that's probably about the same size as the ones we were looking at in that other picture as well. But the idea here is they talk about the seed for the crystal, and if we have a certain kind of seed, then that's the kind of crystals you get. If you start out with rods, then you end up with rod crystals. If you start out with pyramids, you end up with pyramid crystals that can grow from that. So I think the seed of what we create is very, very important, actually.
So to extrapolate on that, could that mean that if you did a caustic coating and you polarized it for the very first coating, that if you kept coating without polarizing afterwards, it would keep on that seed from the initial polarization?
Well, the polarization is different than the seed. The seed is the more the shape of the size and shape of the particle, of the initial plasma, you might say, because it's not a particle to start with; it's a field. But when it starts actually growing, then it grows according to whatever conditions that it's in. So once it starts growing a certain, like what's called the polarization is probably creating a certain size and shape of particle, but it also polarizes in terms of the heat flow, because the heat is flowing along the coil system as you heat it and let it cool and so on. change the colors, then it provides a certain electrical potential in that wire and aligns it electrically and plasmatically at the same time. But that's, I think, different than actually the size and shape of the particles. Although when you heat copper and it goes through the I think it's a miraculous color changes from all the colors of the rainbow basically show up in copper when you start heating it, especially when it's nice and clean. Then each of those colors are, as Annabelle brought up in a previous workshop, each of those colors as they show up are a different size of oxide nanomaterial that's on the surface of the copper. It's the actual nanoparticles of copper are of a certain size at a certain temperature, and they reflect light in a certain way, and they show different colors according to the way they reflect light. So you can actually control the size. It might be better. For example, one test would be to create different colors of copper using the heat, that red, the green, the purple, all these different colors that'll show up when you heat up a plate of copper, for example. And then do a caustic process on top of that, and then do photographs of the different colors of the copper as the seed particles for the caustic. So it should grow according to those different size seed particles, and we should see different sized nano coatings according to the different colors of copper that were used as the seed for the caustic process. So I think that would be a really interesting experiment to do.
From what I understand, each of the colors that it turns, you are actually able to absorb that frequency of energy with that color, right? As well. That's why we want black, to absorb all of the energy.
Well, in a
if
way,
it's a specific color, it's reflecting that energy.
That's right, but it also absorbs other frequencies as well. And the interesting thing about copper, which I was going to bring up here, is getting in some pretty kind of sophisticated stuff here, but is this the one I wanted?
Okay, so the nano coating is cupric oxide rather than copper oxide. I was thinking that because we made solar panels out of cupric oxide a while back, and
you mean cupric, the red? You mean the red oxide or the black?
One oxygen.
Pardon me.
So it'd be 2 and 1 oxygen for the nano coating.
So you're talking about the CU2O or CuO2?
CU2O. I just, right. When you first put it up, it said about cupric oxide, so I thought, I had wondered because we made cupric oxide solar, panel.
Right. Well, you can make a solar panel with the red copper oxide. It works best. Right. And you can actually make them out of the black copper oxide as well. I was just reading about that yesterday. It's just a lot less efficient to use the black copper oxide. But it is actually better in some ways because it is more absorbent. So they actually use it as an absorbent in the certain solar panels because it's cheap. It's cheaper than the other black coating that they can put on. And it works very well to transfer the energy and so on that way.
By the way, I try to share my screen with a little picture about other kind of copper oxide.
Okay, yeah. Wow, I've never seen that. That's like a flaky one. What's the deal with this one?
So different structures can be achieved. So whether more flaky or more crystalline or nanorods and so on. So not all the oxide structures are the same.
That's right. In fact, it's probably pretty difficult to make them exactly the same each time.
Yeah, I think it would never actually really be truly exactly the same each time. Every one of them is unique.
I did sometime interesting experiment. You know, when you put the nano-coated wire, black wire inside, so it's absorbed all spectrums of the light. So you use the normal salt, which doesn't have much, like example, if you use the seawater, it's have a lot of GANs already inside. But if you use the rock salt and you just dilute it with the water and add the caustic, you would not have nothing. But if you put the plate, copper plate inside for some time, it's kind of abstracts the all spectrums of the light. And after, if you add the caustic, you start to getting a lot of the GANs, which example, if you put zinc next to it, or some another material, you kind of pop up only that specific one, which the field like, you know, match. But if you let's say you drain that water off and you apply the caustic to it, you find there is much more was being absorbed in the water, which was not just popped up. This is what I saw. Again, should be tested more.
Well,
but
it's
I think
interesting.
That water could be used to have another type of GANs, which was bedded there. Yeah, sorry.
No, that's good. Thank you. You mentioned.
So this is a.
Go ahead. Sorry.
This is another picture from the same source. So here is the source. It's a Journal of Materials Chemistry of 2006. Hierarchical nanostructures of cupric oxide on a copper substrate, controllable morphology and wettability by Jinping Liu and others. And here it's a description. He used high temperature, about 60 centigrades in alkaline condition, like sodium hydroxide, and on the other picture below, it's with ammonia.
Yeah. It's interesting. They talk about the cauliflower structure. You see in the bottom left there, and
it's
the
a
top
different
left.
magnification. It's same, but it's a different magnification. If you go on a higher magnification, like on the right side, it's 500 nanometers, half micrometer. Then you see more details the structure. And it's similar method to what we use, but what we do, what makes a difference is we use the polarizing with the voltmeter. So our purpose is to get these nanosheets to be smoother and oriented, and not at random. So this is a random structure.
Well, it turns out those little florets that look like little broccolis there, cauliflower, I think they call them, cauliflower shapes, they're actually extremely efficient in terms of, for example, transferring heat energy or in other
It provides
things.
a higher surface, a much higher surface.
Yep, and it's basically like a fractal, scalar sort of structure. And I think that's where a lot of...
What I'd say here, it's the same process like in the similar process like it was shown on Velichkov's pictures. But they obtained a crystalline structure, and here is a more flaky structure.
Yeah.
Although both metals are encaustic, so the conditions which you apply are very much important. Also, time of growth.
Yep.
How much time you allow for growing.
The pH, temperature.
And probably the purity of the copper also. And,
and how it's prepared makes a huge difference. They determined as well. For the best nanopyramids, they prepare the copper very exactly by polishing it, several grades of sandpaper down to 6,000 grade sandpaper, and then you clean it with 3 types of cleaners, alcohol and acetone, and then you blow it off with compressed nitrogen and make sure there's no oxygen gets on it and so on. Then they put it in the caustic or do other processes like the heat treatment, and that provides those seed particles that are so important to create the correct crystals, and they are crystals that actually grow of the copper.
Yeah. So just I'd say about the remark which was posted with the first photos which you have shared from Facebook, that it says no signs of graphene. So I'd like to see somebody to show such a similar magnification electron microscope picture of such a graphene structure. How it looks like. Because it will not look like the theoretical drawing which we make it on atom level.
Yeah, like the one two-dimensional graphene thing.
They're mostly a hexagonal shape from what I've seen at least.
Yeah, but not at 1 micrometer magnification.
Yeah, you get a bunch of layers and it turns out the edges are all kind of wrinkly and sticking up and so on. And the edges are the very important part, apparently. That's where all the actions happen on those several atomic layer things of graphene. Alexei has his hand up here. Like to say something, perhaps?
Yeah, I actually had a question with regards to fire coating and the final units. If it's necessary still to have a GANS coating after you do the flame coating, or if that's something that can be omitted.
What do you think the GANS coating does for the situation?
Well, as far as I understand it, it has a connection to the center GANS ball. So the magnetic fields are able to traverse between the two and have a kind of a flow going on. So I've heard some like slight suggestion that you don't have to, but I still do. I think it's necessary, but I'm just kind of wondering if anyone else had any idea on that.
Well, there's one other connection with the GANs as well, which is to ourselves. So perhaps a unit that had GANs on it would have a better connection to the beings in that environment compared to without the GANs, as well as a connection to that central GANS ball, which is all critical as well in terms of the free plasma and the connection of the free plasma inside of each single GANs, which is also connected to, all free plasmas everywhere, basically.
Yeah, I would say that it would be absolutely necessary because you're looking for a gradient so that you can hit every spot. Think of it as like a DNA spiral. You can hit every spot in between where the lowest GANs you have and the highest GANs you have. So each element or whatever in between, right?
Yeah.
And okay, so what would be the mechanism? What's going on between the actual nano layers and the GANs itself? Anyone have a visual on that?
I would think that the magnetic fields that are coming from or through the GANs would be directed through the nano layers that we're polarizing on the coils. And so they're being forced into a particular direction to give us the flow that we're trying to capture or utilize.
Okay.
So the nano coating provides direction, basically, right?
Yeah, that's how I see it.
Yeah, that's kind of how I saw it as well. like he talked about using a potentiometer in order to get what you wanted out of it, which I kind of saw as, like I said, the DNA coil. You're hitting the spot that you want to produce in the feedback.
Okay, well, so we're on this. Let me just, oops. I just had an idea that maybe I can share something here. Are we on the right one here? Let's see. There we go. You see a whiteboard? Is that the whiteboard? Is it white?
Yeah. Yeah.
Okay. Let me see. What I was thinking was, if we had, let's say we have our copper surface, and let's say we did have these pyramids. We've got little nano pyramids all over this copper surface, let's say.
I don't see any drawings if you're drawing already, Rick.
Yeah, neither do I.
Oh, okay, maybe I have to do something. What do I have to do here? I got something else going on. Definitely too many windows. Not that. Okay, I've got the whiteboard up. You can't see me drawing on the whiteboard. Okay. Stop the share. Try it again. Whiteboard. Start that.
Yeah, there we go.
Oh, you can see it there now? Okay.
Yeah, beautiful.
Okay, so if you had little pyramids, I'm contending, all over our copper surface, let's say. And then we have the, let's make GANs say, we have this GANs monomolecular material that's kind of, we call it, Mr. Keshe has brought up this term several times recently, so I think it's important to think of what is monomolecular. What does that mean to people?
To me, it's monatomic, just like the Ormus that they messed with.
Well, okay, but you can't have monatomic if it's got more than one element, though.
Right, so it's the same concept except at the molecular level, not
Right.
the atomic level. So it's just
Okay,
bigger.
good, thank you. Yeah, yeah. So, for example, copper oxide. Let's, Cu and O. So basically, you've got, two units that are connected. We call it being bonded or whatever. And because it's two things that are not exactly equal, that means this monomolecular unit, let's say, we'll call it a unit by putting a circle around it, it's unbalanced. It's going to have a more of an interaction with one side than the other. You could say that in chemical terms, it has more of a charge on one side than the other, or it's just an unbalanced entity. Okay, so an unbalanced entity tends to spin when it's under fields. So what I believe can happen with this situation between our nanomaterial here, our little pyramids, which we know, I could show you, I want a purple, I want this pink will do. I could show you pictures of nano pyramids like this, and they've done tests on them that these pyramids resonate. Okay, they're a resonating structure, and they end up creating a rotating magnetic field on top at the tip of each of these pyramids. All right, so essentially you've got a sheet with all these pyramids. It's like a sheet of plasma on top of these pyramids. It's a sheet of rotating magnetic fields. So each of these fields is pinned in place. So they're not wandering around. They're on top of each of the pyramids. So if you look at this situation, maybe this one situation, say right here, we've got this rotating structure. We've got the pyramid that's locked into place, and it always has this rotating magnetic field over it. You can't get rid of it. You can't. It's just there, just due to its size and shape. Certain size, certain shape, it'll resonate with a rotating magnetic field. That's just the way it is. All right, well, what happens when this particle, or what we call a particle, it's a GANs, which is in between, somewhere in between gas and solid, and it's got plasmatic parts to it, let's say, but somewhere it's between a gas and a solid. You could call it a particle, but it's a plasma entity. It's whatever. It's this couple of rotating magnetic fields, as far as I'm concerned, because when it comes right down to it, all the atoms inside this copper and all the atoms inside the oxygen are just rotating magnetic fields. And the whole thing is just a rotating magnetic field. So essentially right here, you got this rotating magnetic field. Okay. So what happens is this rotating magnetic field, or not even magnetic, that's called a rotating maggraph field. It meets up with this rotating, what they call magnetic field, but they don't even know really what it is. They think it's magnetic. Well, it's my presumption and theory that these fields are interact. It will cause this to rotate faster, to gain the energy from this field. And that's why the GANs is a perfect material to interact with the nanosurface, because it can gain that energy and it's rotating. And it won't look any different to us. It won't even respond any different. We won't be able to necessarily get that rotation out of it just whenever we want, until we figure out how to. But like any ball that's spinning, it spins faster. It has more energy. And it turns out the scientists have just recently started to be able to actually measure rotating monomolecules, and they rotate at like 4 billion rotations per second or something in that range, and that's sort of normal. And then what happens is, if you subject this whole thing, these rotating particles that they measure at 4 billion per second, if you give them a magnetic field, or electric field potential, all of a sudden this can go up to in the tens or even hundreds of terahertz. Instead of billions, it starts to get into trillions and quadrillions per second. So essentially, and when anything that rotates has essentially like kinetic energy that you can calculate according to its RPM, and it starts to multiply, because it's not just the revolutions, but it's the revolutions squared, that the RPM squared. So when this goes up from 4 billion up to 10 to 100, 4 billion hertz to terahertz, then you have in way more than thousands of times more power added into this. It's in the millions and billions of times more energy from these spinning entities. And they may look exactly the same as they do now. Or when they get to a certain spin frequency, they might just light up, or they might just float, or they might just do something. In any case, they're spun up, and we can take advantage of that spun up energy if we know how to tie into it to spin them back down again, let's say, and release that energy. Anyway, that's my little spiel on that for now. I could elaborate more probably, but I'm getting already pretty far-winded here.
Yeah, actually, I really like your explanation, and to me, that's also a very good demonstration of, or what I understand, the principle of how the GANs is formed in the first place, where those pyramidal structures that are giving off the vortex magnetic fields or maggrav fields are creating the condition for the homogeneous metal material to then mix with oxygen in that particular spin to create that GANs material.
Well, imagine when these little guys here separate from this surface where they've been growing, they got more coming in underneath them, and we put them in under certain conditions like the salt water and so on, and these guys are spinning magnetic fields, little pyramids, and that comes off, and now it's a free entity. Still got its spin because of its structure, its size, its shape, and then this structure is basically it's become self-contained. It's a self-contained plasma. It's already got the magnetic rotational. It's already got the gravitational rotational. It's all set to go. It's its own entity. If it wasn't for gravity crushing the heck out of it most of the time, it would probably be quite happy separated out from these other bits and pieces here that normally get all coagulated together, and even in water, but in air they get totally crushed and don't work as well, and the way I understand it, because they lose their, instead of being a nice free field like this, it suddenly gets locked down into a physicality structure and doesn't function as well. It doesn't have the same range of fields as it would as it's floating in space. And in water, these fields would be contained more, but not as much as when it's stuck on or inside the physicality itself, where the fields are really tight inside the physicality. They're going to be, back to back, just jammed in little things. So you can see how especially with certain shapes, when they release into make the GANs, that it would make sense that the shape does matter and the size of whatever our nanomaterial is on that copper plate. We're probably getting all kinds of different GANSs just from the size and shape of those initial seed particles that we're making on the plates, because we never had a good picture of the GANs. It's hard to get a picture of GANs. It doesn't show up in the X-ray diffraction because they dry it and crush it and powder it and jam it into their mechanism, and they're trying to measure this beautiful entity up here that's all expanded out inside its expanded out plasma, and they crush it and dry it first, and it becomes like this, and then they crush it and smash it and bash it, and it's all like a piece of nothing at the end of it. It's lost all of its goodness. And then when they try to measure it, they get what's called an amorphous substance in the XRD or X-ray diffraction pictures of it. And so you got a graph of all these peaks and stuff, and you got a whole bunch of stuff that's all underneath in the graph, and they just call it amorphous substance, since our XRD only measures crystals, and we've crushed all the crystals. Well, we'll just call it amorphous substance. We can't measure it. We cannot. XRD cannot measure an amorphous substance. It cannot tell what it is. It has no idea other than it's the stuff somewhere in the graph here, and there's some numbers, but it's such a large, broad range that they can't tell any exactitude of what this stuff actually is. So we get all our nice GANs, we take it to the test place, and they crush it beyond recognition. Nice, eh? It's like taking a classic car to the crushers, and you think they're going to fix it up for you and detail it. Instead, they put it in the crusher and crush it. Ah!
Totally takes it out of the natural state that it's in.
Yeah, that was my 58 Chevy, and it was so dear to me. Crushed beyond recognition. And then they test it and say, yes, this is just metal. There's no car here. Well, yeah, you crush it up, melt it, you get metal. Hello? When it's in its beautiful form, when it was made, it was had a name, you know. Anyway.
So, Rick, let me kind of see if I understand. You're saying we're kind of harvesting the magnetical field from the nano coating with the GANs rather than harvesting the GANs with the nano coating.
Well, where does the GANs come from? And which GANs first we have to clarify, because in this case there would be copper involved with the GANs, the fields of copper. And with the CO2 GANs, you've got carbon and oxygen. It's a different situation, and these copper pyramids wouldn't be actually entering into, they're part of the equation, part of the solution as ions and, you know, plasma fields inside the solution and so on, but in a different manner than the actual entities being part of the GANs itself.
Doesn't it also depend on what voltage that you or amperage that you provide? If you give it a different energy level, you'll get a different structure or a different form of GANs. Like, for
Absolutely.
example, CO2 GANs needs very low current.
Yes,
whereas
extremely
copper,
low or no current. In fact, the CO2 GANs, you want to drain the current. You don't want to have a current.
Oh, otherwise you get more, I think, zinc oxide, right?
That's right. So you want to put an LED or a small motor between the two plates and cause a drain on the system rather than putting electrical energy into it.
Yes, and Armin suggests a plasma battery connected.
Right.
To help get your GANs going.
That works really well for CO2 GANs as opposed to getting zinc oxide. It made a big difference, actually.
Having the plasma battery, you mean? Is that what you're saying?
Yeah.
Okay.
Yeah, instead of a power source.
Mm-hmm.
Like, I noticed when I connected my plates with the zinc plate and a nano-coated copper plate with the regular battery, just a AA battery, it gave me a much thicker white color GANs, whereas when I used a small LED or just nano-coated wires with a plasma battery, it gave me a much more fluffier, kind of pasty-looking GANs, which I assumed was CO2.
Yeah, it's generally the assumption on the fluffiness quotient there.
I've had the same experience with the plasma battery helping with the CO2, not necessarily the copper though. I have to use a little more voltage with the copper.
Yeah, or maybe it just takes longer if you're to use the plasma battery with copper.
That's highly possible, yes.
And along the ways of nano coating, I could pass on a helpful hint, my hint of the month for nano coating, you might say, which is, and I talked briefly earlier about preparation of the copper surface before nano coating. Makes a huge difference in the product that you get for the nano coating. So along those lines, if you use, well, I use, what do you call it? Vinegar, acetic acid, vinegar, and salt. Okay, and dip the copper component that you want to nano coat in the vinegar and salt for at least a few minutes. You don't want to dip it too long, it'll start etching into it. I'm not sure, I haven't done tests to find out how deep the etching is best, but what happens is you'll notice even after a minute or a couple of minutes, your copper will be super shiny. It'll come out super shiny even after immersion in the vinegar and salt for a few minutes. And after, an hour or two, it's as shiny as it'll get, basically. It's just beautiful shiny. And so what I do is I take that and then immediately, just without even wiping it off, just shake the excess acid off, and immediately put it into a caustic bath. That is, immerse it in hot caustic, and then pretty much within minutes or within an hour or so or less, I figure as soon as the caustic cools down, do the caustic bath, the caustic vapor. And I got really nice, shiny, black, non-conductive nano coating. It starts forming very quickly and very nicely on that surface. I think that it makes the whole process go much faster and gives a far better quality product when using the that kind of process, that the surface is cleaned and scoured and basically etched into with the vinegar salt combo.
Yeah, that's really good. Actually, it also removes any residues or oils that were on the surface.
That's right. And every time we handle copper wire, inevitably those oils from our fingers get on the surface. Plus, there's oils from manufacturing alone that are also on there. Plus, the oxidation from whenever copper is exposed to air, it starts oxidizing immediately. You may not see it immediately, but it's definitely putting oxidizing layers on. And it may not be the layers that you want as your seed layers for your nano coating.
One thing I'd like to quickly suggest too, if you're going to be doing a flame coating after you clean with vinegar, you might want to try to quickly dip it into a sodium bicarbonate solution to neutralize the acid, and then quickly rinse it with water before you do the flame coating.
Yes, that's true. Otherwise, even if you do it in the baking soda or some other caustic or something, if you get some of that on the coils and heat them, it'll have a nice color of yellow from the sodium in the flame, and probably contamination of the surfaces and so on from the acids or alkalines. So probably good to wash with distilled water after that process if you're going to do it that way.
Do you use a multimeter or some way to bleed the excess amperage off?
Well, that always seems to be a good idea.
Before doing the nano coating, like before using caustic or before doing the fire?
Or after the caustic process, I think. That's what you mean, Denny? Yeah?
Yes, this is Denny. It seems to be the practice when they show the technique that you use your multimeter in every several hours during the drying stage. You bleed the energy off of the plate that you're nano coating. But I think the reason for that was also to set up the magnetical structure of the plate as well.
Yep. You're basically giving there an electrical pressure for the layers to really come down and form.
Yeah, he's talked, Mr. Keshe has talked, and it's also in some of the sciencey articles that if you put electrical energy into the layers, it tends to fluff them up and separate the layers. So if you had layers that were nicely made and all vacuum in between and all the right distances between the layers to set up your plasma energy superconducting, and then you gave it too much energy and it fluffed it up, and all of a sudden you'd have a bunch of stuff that's not working because of the clearances aren't correct, and the in between all the fields is not, they wouldn't be interacting the way they were when it's a tight configuration. Air could get in, and then it destroys any of the ability to act as a plasma in a more or less vacuum environment of close layering. Makes a huge difference. As anyone who's played with a vacuum chamber and high voltage, if you can't get any of the interesting effects until you get down to a certain point of vacuum, and then all of a sudden the effects kick in.
Well, I just was lazy and I let mine age for several months. So I don't know what that did with them.
Aging is good, I think, when it comes to some of these coatings. But on the other hand, it's some of them can get, when they're aged with air, it's sort of can destroy them or change them into different materials and so on. I think we should probably wrap things up here. I'll just show. Yeah, go ahead.
Before you wrap up, and just couple thoughts.
Mm-hmm.
I showed you that thing which you call the baby inside. It didn't give me the piece. Like, I think it's like, remember Mr. Keshe was saying, like, if you want to make the wall, you have to make the 3 layers like a skin does.
Mm-hmm.
So what about if you because like our planet is in a part of the galaxy, then the galaxy is a part of the universe. It's like always, it's like one is inside another.
Mm-hmm.
So I thought, like, what about to create, because in the where I put this small coil, there is the free plasma inside, correct? So now you make it even much stronger by putting another one inside.
So you mean by creating a smaller free plasma out of a smaller coil inside of this opening or the space?
Yeah, and the gravitational inside. I can show you quickly. Maybe it will be easier to understand.
You mean like from the picture you had before of the of your stacker with the little small one?
Yeah.
Go ahead and show us there. It's probably easiest.
Yeah.
Someone showed a picture recently I saw on Facebook of the interacting levels.
Your screen must probably you have to stop sharing yours.
Okay, where is? Okay, try that. Okay, go ahead.
Mm-hmm. Okay. So I thought, like example, I use this one. So this is the gravitational. It's have 81 turn, and because it's a plastic, it's quite it's become very thick.
Mm-hmm.
It's become very large, and this one fits very nicely inside. It's difficult to hold, but the point is plus minus. I will finish this today, and maybe I will show Mr. Keshe a question. What about something like that?
Yeah, I think you're onto something there, because now you're forming you're using 3 separate coil sets, kind of making 3 layers of magnetic fields together.
The point is here is missing. This is the gravitational. Here is missing. There are another one which will goes in this direction. You understand? It's like, if I show the small one, it's exactly like that.
Mm-hmm.
Yeah.
So you need another one around the whole thing.
Yeah. Here I miss one. It's just gravitational. So here inside there is free plasma already, correct?
Right.
So if you put this one, you make it more stronger, correct?
Well, what do you mean by stronger? Like a
higher strength,
more volume behind a water hose, stronger, or more like plutonium as opposed to hydrogen?
Yeah, it will create the stronger the field gradient, which you need for lift.
If you want to create a stronger field, you can do 3rd wire, I think.
Yeah.
Not
you mean
that way.
Like that, yeah?
No, you have 2 wires going, two coils going one into each other with a 3rd one.
Yeah, that might also work.
You mean more like here, just you now going to, instead of what I did here, just you going to another one in.
Yeah.
Yeah, this can be used also, but it still can be used in that formation.
We could do all of them, put them all together.
When you open up plasma, you can strengthen it by, putting energy in it or taking energy out of it.
That's right. Essentially, you're rotating it up. You're speeding it up, right?
Another, coil inside to strengthen it.
What I understand, what creates the energy, the amount which we need, it creates you need the demand. If you make this coil, like example, this one is with the plastic together. Now this is with just pure metal. So it will create the gradient. So we're gonna feed each other. And then you also conditioned by the GANs, you make very weak one here and very strong here. So it will pull, and that pull will gonna make the torus field, react more stronger, or I don't know what would be correct word. Maybe stronger is not really the correct one.
Actually, first we need to, play with this cross.
This one?
Wires. No, the other ones. Yeah, this ones. And to see if we can open up a plasma. I think you need a plasmatic feed, into the coils. So if we can make a stronger batteries to just ignite. After you open up a plasma, you don't need the coils. You can take it and create another plasma, actually.
Yeah, it's true.
So,
but at the moment, I still don't understand how to hold the plasma. I understand you can hold only with another fields. You have to still kind of engage it.
Do you already have that configuration of your coils? It will hold.
Yeah, I mean when you remove it.
What do you mean move it?
When you don't have any more coils. When you're saying when you made the plasma, you don't need the coils anymore.
When you open up a plasma, you don't need the coils to support it. It's already on.
It's self-containing, right?
Yes, definitely.
I mean, how you will move it?
What do you mean, how you will move it?
Better have a fast-moving
mind.
You
it's always inside. So if you don't have container, it's it's free. It will decide where it's.
That's why the name is free
plasma.
That's why
you are connected with it. So you're moving it. So you think you're moving with the coils?
Yeah, it's correct actually. Talk about it.
It's like trying to move a tornado with your hand.
Coil stays. Plasma goes.
Yeah, thank you.
You're welcome.
Hey guys, can y'all hear me?
Mm-hmm.
I know y'all been up a while, and I cheated and got a couple hours sleep. So if this has been brought up and discussed, I'll catch it on the recording. But was there any discussion on how to check for or identify that you have a free plasma with some kind of meter or measure or light or something?
Tonight or in general?
Yeah. Well, I know it was mentioned last Thursday when Ali showed his system, and he said he didn't have anything to, to detect the field, and that it kind of got dropped after that for some reason. But
well, he did have something to detect the field because in several different ways. One, they did have a magnetic detector, and they were running around detecting the field using an iPhone and doing field measurements close to and far away from where the unit was.
Okay.
And also, people were using their hands specifically to try to feel the plasma and to interact with the plasma with their hands moving up and down and sideways and that kind of thing. So there's two ways that we might be able to sense plasma, and there's actually many more. For example, they talked about, Mr. Keshe has talked about this before, of having a radio going, and if the radio suddenly stops, then you know you've created a plasma.
Yeah, because it's one of those things where you put all this work into something and you're like, well, it's plugged in, and
Actually, it's not stopping the radio. It's saturating the field so much so you cannot hear it.
Oh, okay, yeah.
Okay, so it'll be a staticky thing, you mean, or just the sound goes away?
The sound goes away.
Right.
When you walk into the room, then sound comes back because you're interfering with the fields.
Mm-hmm.
So it's not more saturated anymore.
Mm-hmm. Yeah, our bodies act as an antenna for the regular radio waves, so that's true.
Right.
I remember in Desenzano, we were opening the door, but not entering the room. You cannot hear the radio. A minute we enter into the room and walk into it, you hear the radio back on.
Yeah, right on.
Yeah. Okay.
I have a similar effect with my voltage detector, my electrostatic voltage detector. If I am holding the voltage detector and I touch the coil, the voltage detector goes off.
Right. I've had a similar thing when I was measuring a field from just a plasma ball voltage supply the other day, where I measured the field away from it, and it measured a certain amount, and it got stronger and stronger, and all of a sudden weaker as it got closer to the ball. And then when it was very, very close to the ball, it finally got stronger again. But there was a certain distance where everything went down to nothing and then came back up again. So the fields were basically balanced at a certain place. I've seen that several times, that phenomenon with a plasma ball, just as a crude example of what we call plasma.
All right, I'll give those a try. Just two more quick things. As far as I know, we twist these wires to make the connections between the coils, and I was wondering if anyone has tried using short plastic or short tubing, like a coupler.
That came up in the last workshop, actually, and that was talked about. And
has anyone tried it?
I think it's been tried, but I don't know if how do we test? We'd have to test and see if it's.
Yeah, you'd have to see if you have a free plasma. In other words,
right.
Kind of the same way we were just discussing, I suppose.
Yeah. So, and I guess there would be no physicality connection as far as having a ohm reading and that kind of thing. It should list as an insulator rather than as a connection between the physicality. So yeah, it gets a little tricky. You would think it would work. It makes sense, especially if both parts were nano-coated and it grew into each other and so on.
Yeah, I was thinking of nano-coated tubing.
Yeah, try using a voltmeter and see if you can get a small reading through it. Because if you get a reading through it, even though it's a matter state connection that shouldn't pass electricity, then you know that you're probably working with plasma there going through.
Yeah. Okay. And finally, how to nano-coat aluminum and how to get aluminum GaNs.
Peter Byrne, your screen is you're sharing your screen.
How to get aluminum GaNs
Thank
the
you.
same way that you're getting other GaNs.
Yeah, just use a nano-coated plate, any metal nano-coated, and then use an aluminum plate.
Oh, okay. So I could just use copper nano-coated plate and then aluminum. Okay, I got it.
Yeah, for the GaNs. For nano-coating aluminum, that's I'm not sure. I haven't tried that yet. That sounds a little tricky because caustic reacts with.
Yeah, I know.
But still, it produces essentially aluminum oxide nano-coating. But yeah, it's tricky.
Yeah, I used it.
It's hard to do with aluminum foil, for example, because the foil tends to evaporate. It's a great way to create hydrogen, by the way. Go ahead, sorry.
When you put in a caustic, you create nanoparticles of aluminum.
Mm-hmm. Did you just say something about creating hydrogen GaNs, Rick?
No, creating hydrogen itself, you just put aluminum foil into caustic, and the bubbles that are formed are hydrogen, pretty much pure hydrogen.
Yeah, it was just, I used the caustic with a piece of aluminum to try to get the nano coating off of plates I had already used to clean them up, and it actually worked pretty good.
Yes.
Oh, by the way, I've got something to show about that. I'll be right back. Throwing in things.
Has anybody figured out how to make the hydrogen GaNs yet, by chance?
Hydrogen GaNs?
Yeah, I'd like to have some of that.
Actually, when you hang plastic, let's say, what I do every time I do the nano coating, I put Coca-Cola bottle, shredded.
Let me just see if I can.
After that, I collected the residual from bottom, the caustic. Then I clean it up so I have white GaNs.
Mm. When Ali showed his system, he talked about using a heavier GaNs on the bottom coils and working its way up to the lighter GaNs towards the top. And he mentioned CO2 at the top, which wouldn't CH3 be the lighter than CO2?
Definitely.
CH3 is lighter?
I mean, that's my question. Yeah.
Yeah.
But if you use with your nano coating, if you put a Coca-Cola bottle or other plastic, shred it and put it inside, afterwards, when you collect the residual from it, I think it's a hydrogen GaNs too.
So that would be the thing to use around the top of the coils.
Yeah, I always collect that residual. It's kind of silverish, grayish, GaNs coming out.
Interesting you mentioned the magic 2 words, Coca-Cola, because I was just about to show a way to remove the nano coating using Coca-Cola. You can see what it's done here. I had a nano-coated coil. I put this in just for a few hours, or actually it was overnight, but about 8 hours or so, and dipping in the Coca-Cola, and it took off the nano coating.
Wow.
I'm not sure if you have a visual on that, Rick.
Oh, maybe didn't share properly or something. Sorry about that. Let me...
Actually, Coca-Cola is making very... Hello?
Yeah, can you see that on the screen share now?
Yeah.
Oh yeah, that looks good.
Yeah, it's beautiful.
That's the part that was dipped into the Coca-Cola. I couldn't believe it. And it's also very good for preparing the plain copper. In the same way I mentioned the vinegar and salt method, I tried the same thing with plain Coca-Cola. I put, in fact, I put this piece in and got it. No, I'm sorry, it was another piece, and it got it super bright and shiny by just putting it in the Coca-Cola. It's an excellent copper cleaner. And then just shake it off a bit and immerse it immediately into the hot caustic. And that makes a really nice coating because it's the same thing where that surface has been exposed, that copper is just ready for that oxygen, like give me some oxygen here. And instead of giving it air, which, if you allow it to dry in air, it's going to start its oxidation process, but not in the way that you want it. You want it to have that shock of the heat and the caustic and the sodium and the hydroxides and so on, all working away at this. And I think preparation in Coca-Cola is a good way to prepare the surface and then just immerse it into the hydroxide. And you've got also in there, you've got the sugars, which is hydrogen and carbon.
Right.
And that's going to give a little bit of carbon in with the copper oxide coating. And I think that could be beneficial in some circumstances.
That's pretty cool, actually.
I've got to interrupt, Rick. I see that Robert's still here, Robert the CAD man, and
Okay.
Armin's here. And Robert had a couple of questions for Armin. Wanted to show Armin his CAD drawing of the battery. Are you still here, Robert?
Yeah, I'm here.
Didn't Armin's here too? Didn't you want to show Armin that drawing of the battery and ask him a few questions?
Sure.
Well, but Rick, you still have the floor. I was just letting you see if I could still rally the cause before the night toll.
Well, we could get into that if Armin wants to, and
Yeah, go
John.
ahead.
Okay.
I just came home.
Yeah. Well, I've been at it for 5 hours here now, but yeah, we
If you want to continue,
we could go a little longer. What happens though is the video gets really long and it gets really hard to edit later, and it gets really hard to publish and everything else. Is why I like to keep them to 3.5 hours or so maximum. We're already up to 5 hours, so it's getting on. But that's yeah. But we're hot on it now, so why not continue? If you guys want to deal with that, that'd be great, because these brainstormings are good to do, and we only have this once a week basically at this point. So what do you got there?
Can you stop sharing, Rick?
Sorry, I got to stop talking and sharing and allow you to stop complaining and allow you to do what you're supposed to do. Okay, go ahead.
Oh, that's beautiful.
I was trying to do an EMS study. I got that software, Rick.
Oh, yeah?
EMS. I gotta learn how to use it, though.
Yeah, it's all in the setup, isn't it, on that stuff?
Yeah, the question was, is this what you were describing, Armin?
Yes, you've done it perfectly.
Other than, what about the coil direction? Is that okay, Armin? Or?
Guys, understand, it's anti-clock or clockwise, it's a direction of the coil. If you start with clockwise, do it with the clockwise. If you start it with anti-clockwise, you do it with anti-clockwise.
Okay, so...
We add to the plasma. If you do the same, let's say, clockwise or anti-clockwise.
Okay, right. So this would be correct in terms of itself right now, or its system that it was built
Yes.
for, let's say, which would be all the anti-clockwise type coil, or
Yes.
what we call the clockwise wound coil. Anyway, I don't want to get into that so much. I didn't want to distract. Go ahead. So, what would be the connections here now, Armin? Would any
You
of
can
these
connect
connections?
3 outside coils together, or inside the coil, the pin actually your gravitational, your minus, and the other ones are your plus. So you can collect each coil the energy. So this way you can add on.
So, would any of the coils attach to that minus coil and minus wire in the middle in terms of just
they're
wrapped
not
around?
attached.
Okay.
No, you can attach them 3 together.
Mm-hmm. Or in different circuits, depending. Could each of those wires go to a different reactor? I wondered just now. Each of those 3, in fact 4.
I mean 3.
Well, the red, the purple, and the green, what if they went to 3 different reactors? We have the 3 different reactors with 3 kinds of GANs, 3 strengths of GANs. We have 3 different size coils, so obviously different strengths of coils. Maybe each GAN should have its own coil.
Or rather, each GANs could use all 3, and depending on which one you select, you give it a different strength of magnetic and gravitational
That's correct.
field.
Anyway, you're going to have a different strength because you are tapping into the different strength of plasma. Each coil is bigger than another one.
Right. So
that's why if you do collective, so you have more.
But you could put, say, the CO2 reactor attached to the green coil, and the next in order, and so on. With
you can do different materials: 1 aluminum, 1 brass, and 1 copper.
Mm-hmm.
Armin, right?
What is it?
I was just going to ask if you put anything between the coils. I know
Yeah, you put GANs between the coils.
Okay.
And then a matter state in between that too, right? Like aluminum foil or something.
You don't need that. If you want a total plasma, why are you going to matter state?
Okay, so like just GANs coated coils.
GANs coated coil. Yeah, because it's nano-coated, it's already insulated. Each wire. That you can do even with the cover plastic, whatever wires we have. Don't take the plastic part out of it. So just that the guy showed a yellow winded coil, just do that way. If you have a plastic already, it's like plastic tube covering your, copper wire. So you can nano-coat together. Mr. Keshe was talking about nano-coating tube, plastic tube. You already have it on your wire.
So you would just throw your coated wire and nano-coated like you would any other wire?
Yes.
You wouldn't use a
Okay.
flame method, probably.
You already have a copper in a plastic tube.
You can use the flame method, maybe only just caustic in that case.
Yeah.
Feedback system on this.
Just remember how we done, nano coating in a plastic in a Coca-Cola bottle. If you put the tip of your wire into the Coca-Cola bottle and seal it, and even it's a 2 meter long, after a month, whole wire is going to be perfectly plasmatic nano coated.
And that's without the wire even touching the caustic, because it's
No, the tip of the wire is touching the caustic.
Oh, okay, just the tip. Okay.
It's the tip, but you can take it 10 meter long and you leave it like that. It's going to be whole wire. It's going to be nano coated and perfectly nano coated, guys.
What about connecting it to the load side of the MAGRAF system?
Yeah, you can do that way too.
That seemed to me that would nano coat it.
Anything what comes out from your MAGRAF and you connect it, it's already a nano coated.
Yeah.
Any material, you remember, in one of the teachings that Mr. Keshe was talking, to connect the like aluminum coil, aluminum wire, zinc wire, and different wires, and hang it out, to see if you walk in, you can absorb all the fields. But even if you don't need to nano coat them, you just can do the simple wire. When you connect it to your unit, it's already going to be nano coated. So this unit, it will make your all nano coating actually in the future. You don't need to use caustic.
Would this nano coat the plastic as well?
What is it?
Would this nano coat the plastic as well?
Definitely.
Good.
If it's nano coats copper wire, why do you think it's not nano coat the plastic?
No, I'm pretty sure it's do it from inside. What about outside? That is more.
You don't need the outside.
Because I thought, like, if I do the coating with the caustic from outside, I can apply the GANs on them.
What do you mean?
Like dipped in a GANs, like what we was doing with the normal.
But you have already everything in that wire. Why you need GANs?
You would put a bit extra, extra gradient.
You can do one coil with plastic on it, and one coil you can do just a bare coil, nano coated, and dip it in a caustic, in GANs.
Yeah, that's what I mean.
One coil you can use with the GANs, and the other one just already have a perfect nano coating inside and a tube.
Yeah.
And this plastic is CH bond, so you have the supply.
I can show a tube like that, Robert, if you can stop the screen sharing for a second there. Let's see, here we go. This is a little plasma battery I'm putting together. Let me just make sure. Yeah. I've got a wire that goes into it. This is...
I cannot see you.
Oh,
what about others?
Sorry, let me get... there we go. So this is just a plasma battery I'm putting together just to play with. And I have a wire that's clear coating on it, clear insulation. It's for stereo. It's really nice quality wire with many strands on it, multi-strand, eight.
Those are oxygen free too, right?
Well, that could be. The interesting part is that the fluid will travel through the wire. It's stuck in caustic there now, and you can actually feel the end of the wires gets moist. At the end of the wire at this end actually gets moist from the caustic, and you can see it's changing now through the whole thing. It's all turning black. And this other short piece I had within a day, basically, of dipping one end, it's just gone right through to the other end and starting to turn the whole thing black.
Even if you don't dip it in a caustic end, but close the chamber with glue it, still.
Right. Yeah.
Have the same effect.
Yep. So it's quite amazing, actually, that it can travel. You wouldn't think it'd be able to travel. The vapors or
That's a pure,
the plasma essentially travel through the wire, but
You know what I have experience? I did composite GANs. There was many materials in it, And the wire, you know, I put the battery in the end, so it became heavy, and it's lying down the next to the container, and it was made. I think it's extracted from that container about 200 grams of water. I had a very huge container, and each time when it falls down, it makes a lot of that water, and it doesn't do that when it's have a fat layer. Then it's dry completely. When I remove the fat layer, it's become quite like a spot of water. First, I thought I have a hole or something, but no. Then figure out it's dripping from the metal somehow. I think it's this what Mr. Keshe was saying, transferring you know fields from one to another place.
Yeah, just like that experiment Alex was doing with the orange, where they were getting the oil transferring through the magnetic field flow into the container. Similarly, yeah.
Mm-hmm.
I got another quick question. I was doing some, well, I'm starting to feel like Rick, a little bit Zoom drunk. Nano-coating for CH3, and I ended up with really two materials. One responded to a earth magnet. In other words, it sticks to it, but it's a very light bond. You can just about shake it off in water, but it does hang on to it. And the other material doesn't. Supposing the other material is the CH3, this other that responds to the magnet, I'm not sure what that is, and I guess my question is that of any use?
It responds to the magnet. What color is it?
It's pretty much the same color as the CH3. It's dark brown.
And yeah, be iron oxide probably.
Yes. Yeah. But it's a very light bond, though. It's you know, I mean, you know how hard it is to get a magnet off of one of those magnets off of something, but you can actually shake it off in the solution. Well, I guess it may be good for something.
Yeah, definitely. Probably in your heavier mix of cans if you're trying to do that.
Yeah. Yeah.
Or even I think for plasmatic heaters that might have an application for the iron, because we have iron in our blood. So if you're able to perhaps make some kind of field interaction between the bands and your own, you can kind of warm yourself up that way.
Yeah, that's something I was really interested in from the get-go, is either warming up or finding a way to heat something to create heat out of these units. I know, I think a while back, Mr. Keshe started talking about come first of the year, going to get more into basically attachments. In other words, attaching things to the magrabs and developing heaters and other things. Hopefully a heater would be right at the top of the list.
Yeah.
For heaters, from what I remember, from what I've picked up, is when you throw in a matter in between the plasma and GaN states, then that interaction between the matter and the higher states is what gives you that heat. So, for example, when some of the capacitors or batteries have extra matter in them, like metal shavings or like an insulating tube, a heat shrink or something like that, it gave off a lot of heat when there was plasma going through it. So you could try throwing in matter into your plasma system in a certain way that you can kind of extract heat, like maybe even just as simple as wrapping your coils with some kind of plastic or shrink wrap.
Right. So I wonder if, well, for instance, this iron oxide might actually produce some heat off of, say, a copper pipe that was nano-coated, and you coat it with, say, CH3 or something, and then slap some of the iron oxide on it. I wonder if that would give you some heat. Try that.
Try it.
Yeah.
You never know. If you have a rotating magnetic field in a copper pipe, will heat the pipe. So if that's a clue.
Yeah, I thought about using various weights of GANs inside the pipe. I mean, the inside and outside are nano coated, and working, heavy to light going up, and attempting a, I guess, what's it called, a vortex.
Mm-hmm. Yep, you'd have a good gradient, and maybe that's the way to do it. Insert a rod as a control rod or something down into the middle of it.
Mm-hmm.
Okay, guys, I gotta wrap things up here now. I'm fading away. So,
yep.
Thanks. We went to a lot of stuff tonight. It was good fun. Thank you all for participating. Hey?
Thank you,
Rick,
Rick.
this is Robert. I had a meeting the day after Christmas. I'd like to schedule a time with everybody when it's good for them. It was at midnight my time, which I don't know what time exactly that would have been you guys' time, but it seems that's about when all the meetings start is in between then. What's a good time
What's
and
that?
day?
What do you mean, to make your own meeting?
Yeah, just to host one. We talked about it last time, and you said that there may be a opportunity to host one. I figured if everybody will show up, I'll do it again.
I'll be there.
Well,
Okay.
Are you hosting on Zoom, or how would you host?
Yeah, I'm hosting on Zoom. ID number 619-402-349.
Okay, well, you could post it in the Keshe Plasma Reactor group. That's a good place to post that kind of thing, and on Facebook and so on. And if you have a
Start this
time,
meeting at 11 o'clock p.m. my time. So is that a good time to start the meetings for everyone to show up?
what's your time? Where are you?
Mountain.
So
Well, I'm all up for earlier, but I'm being prejudiced.
Yeah, I hear you.
I'm on the East Coast.
Who is hosting?
Robert Stubblefield. I'm willing to if everybody wants to, but if nobody wants to, it's
What's your name? I'm sorry.
Robert Stubblefield.
Oh, Stubblefield. Okay.
How about if I'll tentatively schedule like a Saturday at 10 o'clock my time?
Works for
okay.
me.
Well, you could post it and see how it works, basically.
Okay, cool. All right. Hey, thanks a lot, Rick. I really appreciate everything you do for us, bud.
Yeah.
You're welcome.
Yeah.
See you.
Just out of curiosity, how long does it take you to get the meeting on live stream for recording?
The live stream's all automatic. It's up pretty much within a couple of hours of the live stream, or sometimes right away, depending.
Oh, okay.
Good night, everybody.
Thanks for coming by, Armin. Appreciate your comments as always.
Thank you, guys.
Goodbye, guys.
And thank you, Robert, for the beautiful pictures and all the work you do on the background there. Appreciate it so much. It really helps us to figure out what we're doing better, I think. Big time.
Glad to be useful.
Yeah,
thanks, guys.
It's good to be useful, isn't it?
Good night.
Okay. I'm going to wrap it up then. So this is Keshe Plasma Reactor Group for Wednesday. Now it's Wednesday, December 30th. Was Tuesday, December 29th when I started this announcement. And thanks to everybody for attending. It's great fun here. Lots of things came out and lots of good information in there, I think. So that's it for now, and we'll catch you here again next week. And we also have the Knowledge Seekers Workshop tomorrow. That is Thursday at 9 a.m. Central European Time, and that's Wednesday at midnight in Western Canada time. So figure out where you are in between all that. Okay, thanks everybody, and going to end the live stream now, and we'll
Thanks again, Rick.
stop the recording.